will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hey friends, welcome to this video. Now here I'd like to give you an introduction on how to use buttons in Power BI and what kind of buttons are available. If you remember, we talked briefly about them in the interface video where I showed you what's available there, but we didn't dive too deep into that, and that's why I thought it makes sense to have another look here. I'm also using, as you can notice here, the Power BI Advanced Training 2 file, because then we already have a dataset set up, and also we have various report pages we can use with our buttons to interact with them. So let's do that. Let me just click on the plus symbol, and you can use the same file if you want to follow along, or you can of course use any other kind of report. So let's click on new page here, and then let's name this page buttons. For instance, let's call this buttons. Of course, feel free to name this whatever you like. The buttons itself can be found under the Insert tab. There is the option to add buttons next to the text box, shapes and images. And if I click on buttons, there are various options I can choose from. So left arrow, right arrow, reset, and so on. And also here which are new I think in the end of 2021, Power BI introduced that, or Microsoft introduced that, which are the navigator buttons, which is page navigator. We have a look at that. And there's also a bookmark navigator. I won't dive too deep into bookmarks here because bookmarks are extensively covered in my second Power BI course. So if you're interested in that, then you might take a look at that. But in general, what bookmarks do, as a name might already imply, is they can save states in Power BI. Meaning, for instance, you filter your report for certain criteria, and then you want to save this exact state, and you can save them in a bookmark. And then also trigger this bookmark or go to this bookmark using, for instance, the bookmark navigator or, for instance, the bookmark button. That's what they do. Okay, but let's go back to the buttons in general and have a look at what they can do for us. So as an example, I can select here the back button. I can tick this option, and then the button itself is then linked to this specific report page. And I can move the button around the same as I can do for any other kind of visual. The back itself has already an action attached to it. You can also see that if you hover over the specific button. And if I click Control, so my Control key on my keyboard, and click with my left mouse, tick this, then I will go back to my last report page, which is in this case, the final report. But of course, if I, for instance, would go to my top 10 clients first, then I go to the button itself, and then I click on this back button, Control click, in Power BI. So as long as we are in the desktop version, Control click it, and you see that we navigate back to this specific page. So the back button really goes back to the specific page you were previously on. So that's the action attached to it. And if you select the button itself, then of course you can also see the Format Button option here, which is same as for any other kind of visual. But for buttons, of course, there are certain specific features which we would like to talk now. You see that there is an action attached to it. The action is on, and this is why I can Control click here to navigate. If I would turn this action off, then of course this is not longer available. So now I can Control click, but nothing happens because the action is not on anymore. But let's actually maybe start with the general settings. So if you go to General here, then of course you find various properties which probably are also available for various other visualization types in Power BI. So if you select one of them, you can expand it. You can also, remember that, click on the 3 dots here to either expand all categories or collapse all categories. So of course, if I expand all categories, there's a lot to configure here, as you can see. So you can scroll down and take a look at all of these options in here. So for instance, size is the height and the width of the specific button, which you can configure here. Of course, you can also do it manually if you want. You see that those here properties change. But of course, if you want to create pixel perfect reports, then it makes sense to specify this here. Might be easier. And also you can log the aspect ratio here if you want to keep a certain ratio all the time if you change something here. Position, horizontal and vertical, I think this is also clear regarding the report page you're on. You can specify this here, or of course you can drag the button around. It depends on what you want to do. So What else? Interesting, of course, is you can add title. Let me first maybe, let's leave them on. Let's scroll down. I think that's fine. But with the title, for instance, you can turn this on, and then you can add any kind of text title here. So if I specify here a text title and say this is a back button here, press enter, and you see that the back here appears actually as soon as I type it, and it's available here. And I can customize this further regarding the font size, make it bold, and the color and so on. Center it maybe, place it here, and of course make it a little bigger, like that. So depends on how I want to specify it here. So what else? Also note that there are these FX symbols, meaning we can conditionally format something. And you see that if you hover over something, it gives you additional information, which is always a good thing if you have not used it before. But in general, it simply allows the same as for other kinds of options for other visuals to do conditional formatting. For instance, you might say, I don't want to see the back all the time. I want to see a specific text. And I can link this to some kind of other option, right? With conditional formatting. Or I can click here and say, I want to base this on a field value, for instance, right? So I could do that if I want to do that. And I'm show you an example just in a minute, but let's actually explore maybe a few additional things here. Like, as you can see here, text wrap, you want to turn this on or not, of course, depending on the size of your specific title itself. If you turn it off, let me turn it off because I think here I don't want to see any kind of title. For the effects as well, I mean, there's a background color. You can turn this on and you can play around with the color. Take it, make it blue, for instance, play around with transparency. Of course, if you set it to 100%, then it doesn't matter what kind of background color you use because it's simply transparent. For the border itself, you can turn this on. Maybe you want to add some border, as you can see here, as we have done for other visuals. Remember, when we went to our final report page, we also used the border here, for instance, and also a shadow effect, which of course is also available for the buttons. Select it, and if you go to the general section, and let me just go in here and say again, I want to expand all categories to see that. If I scroll down, then there is also here for the shadow an option to turn this on and also specify around with the color. Again, there's a conditional formatting because you can also set this to a specific field value. What I mean by that is, for instance, you create a measure, and this measure only contains a hex code, so a color code. And then you can link basically the color of the shadow to this specific hex code. So that means if I turn this on, you can see here now I have this shadow in here. And if I click FX here, color effects, I could say I want to either do it based on here a gradient, a rules, or maybe on a field value. And then I could select any kind of field which I want. So if I go gradient here and I take a look at the colors, let me go to more colors here. And then you see that here, for instance, I can choose any kind of color, like this one here, for instance. Now I've select something, and this is kind of orange. So let's go with this one. This is maybe this one here, that's orange. And I can copy actually this value here. So this one here, without the hash, Control-C to copy this. And now I can cancel this. And let me just go to my measures table here and right click, create a new measure. And just to show you this, so there's my measure. Let me just zoom in for the measure, and let's call this is my button color. Button color is equal to, and now as within the quotation marks, I can simply paste now this specific, I think I need a hash symbol here as well, the hash, and then the specific color code. And if I do that and press enter, now I have created a field which only stores a color. And of course I could also wrap this in any kind of expression, like for instance, if something happens, then the color should be this, else it should be something else, right? So I could also wrap this and make this more dynamic if I want to do that. But just to show you that, let me just select this one more time. And now I go to the general section and under effects, and let me go to the shadow. And this time I'm choosing the conditional formatting for the color. And I'm choosing a field value. Let's go with field value here. And now I'm searching for color, which is here button color. I select this option and I click OK. And now you see that the background here is this orange, which I have selected. So that's what I meant with the conditional formatting. You can also do this based on a field if you want to do that. So let's explore a little bit more about the button properties, style and action, for instance, because I think those are the most interesting right now. So let me just maybe create a new shape in here. new button in here. And let's actually tick, for instance, the back button again. I just leave this the default one for now and just choose another one to show you what's available in the button section here. So again, you can simply click on the three dots and here expand all categories. Sometimes it's a little bit overwhelming because there are so many options to configure, but still, let's maybe stick for that for now. So what can we do here? Well, interesting, as I said, is that each button has different kinds of states. Like for instance, the default state, on hover, on press, and disabled. That means we can, based on the state of the button, change certain properties. And one of them could be, for instance, here, the style. So this is true, by the way, for all the buttons. So I'm just using the back button as an example, but you'll find this appearing for all the other buttons as well. So if I'm using this button here and I go to the style options and say for the default, for instance, I can change the font color, not for the text, it's actually, but for the icon itself. So the line color here, for instance, I could say this, for instance, is blue, and then you see that the color changes, right? So that's totally fine. But what about I only want to have this or specific options with buttons for a certain state? Then I could say the default state should be black, but as soon as someone, if I click here, hovers over the button, then I want to change something. For instance, on the hover, actually then would like to see maybe here for the line color, I'd like to see a different line color. Then, for instance, I could say I'd like to see this in blue. And also maybe increase the weight, let's say 5. And now, as you see that by default nothing happens, but if I hover with my mouse over the button, you see that now the button changes, right? So that's what I meant when I specified or said that the button has certain kinds of states, and then based on the states, you can change various attributes. For instance, here, the style. So the default is nothing, but on hover, we have seen that that means that, for instance, for the icon itself here, that the line color changes and also the weight of this specific button here changes, right? It becomes bigger. And of course, all the other attributes, like you want to increase transparency, for instance, you can do that. Or for instance, you say on hover, you would like to see a text. So turn on, and then the text, let's say hover, like that. I press enter. And now you also see that if I hover over this, then you see that now there's a text currently in the background of the button, but you see basically what I mean, that you can change any kind of attribute or property for the button based on certain kinds of behavior or interaction from the report consumer. So the same is true for on press and on disabled. So let me go to on hover, and for now, let me actually maybe remove the text. And you also see that, again, there's an FX symbol, which means you can conditionally format that as well, this field. And okay, of course, play around with the font color, the alignment here, vertical, horizontally, the padding, and so on. So let's say we on hover, we had here in this case for the icon itself, we made it blue. And let's say, so for example, if I go in here and say on pressed, this could also be a state. Then I would like to see this, let's say here for the icon, the line color, I would like to see this not in blue, but maybe in, let's say in gray, just to see something different. Or let's use a dark blue. I think this we haven't had that for so far. So you see that if I hover over the button, I'm here. And if I hold Control click here, you see that currently I have still clicked on my mouse. I have not left it because otherwise we would navigate. But you see that now the color is different. And if I now leave my mouse button, then of course we navigate because it has a navigate action attached to it. But that's the general setting for buttons, so you can style them, and this might be sometimes very interesting and an additional report enhancement for your end consumer. So this is for the styling, and as you've seen here, there are various options, again, for the fill, for the border, for the shadow, the glow, and so on. And I encourage you, try those features out, play around with them, and see what fits best your needs. So the final thing is the action itself. The action is quite interesting because this actually means or specifies what actually the button is doing. So you see that if I drag a back button on my, in this case, my report page, then by default, it has the action navigate back to the last page attached to it. Other buttons, or here, for instance, if I go here and click on the left arrow here, see that this button itself has no action attached by default, so I can click here, but nothing happens. But each button has this action attribute. So this means we can turn on the action if it hasn't been turned on by default, like for instance for the back button. And then if you click the action, you see that there are various types of actions which you can select from. So that means that you can actually attach every action to any button. So also, if this is just an arrow and not a back button, but if I like to say here for this arrow button, I would like to trigger an action, I can specify what kind of action it is. And if I would say I want this to be a back button, then I can select it, and then I can use this the same way as the normal back button. So this just means that no button is actually attached to only a certain specific action. You can actually map any action to any button. So if I go back in here and go to the actions here, you see that there are various actions attached. Again, I said that the bookmark as well as the drill through feature are two things which I cover in the second course, so we'll skip this for now. But the other options here are, for instance, page navigation, Q&A, and web URL. So if you know how those work, so the attachment simply, then you also know that the same is true then for bookmark and drill through. You simply attach those features to the button, the action itself. So the back button only navigates back to the last page. The difference here is the page navigation, because page navigation, if I select this one, I could actually specify here itself the destination. So I could say exactly here, okay, where do I want to go? And if I say this button should always go back to, let's say, top 10 clients, then I can select this option, and then it doesn't matter what prior page I selected, because if I now control click here, or as soon as you publish the report, you click simply with the left mouse key, or your report consumer clicks with his or her left mouse key or button, then simply click it and you see that you navigate to this specific page because it's pre-selected in the action of the button itself. So that means something you can set up here for the page navigation. I think that's quite intuitive and easy to use, and that is great. So that's for page navigation. Other options are Q&A and web URL. I mean, web URL is probably quite easy to understand because you can simply enter a URL here, or again, you can simply do conditional formatting and maybe link this to here a specific field, for instance. So if I go in here, I could say a field value, right? Because you can also save a specific URL inside a measure. And again, this could be dynamic, right? Based on maybe a certain selection. But then you simply use the URL in here, and then if someone clicks on it, then he or she goes to the specific URL. So this could be helpful. For instance, if you think about the button, for instance, buttons here, and I go with information or with help. So for instance, if I click on help here, then by default I get this little question mark icon. And if I drag this around and maybe place it here on top in my report page, then you could say you want to add this. And as a web URL, for instance, you could use an intranet site of your company where there's more information regarding certain specific types or things which you show in the report. This could be, for instance, a use case for that. But of course, I'm just giving you here some proposals. At the end, of course, feel free to figure out how to use it best for your specific needs. A final thing I'd like to mention here is that those formatting pane here is currently, at this point in time, for me, still in preview. That means that it might be the case that certain kinds of properties which you can select here are not working correctly. But this, of course, will be fixed with the next couple of releases. So if you already know about them, then just be aware that maybe there is an issue with a certain kind of formatting here or attribute which is not working correctly, but it will work in the near future. Okay? So the last thing I'd like to show you about buttons in general are, if I click on the down button here, the navigator, and specifically the page navigator option. So if I go to page navigator, select this option, then you see by default, let me just maybe select this button here and also drag this down and also remove this, drag this down, place all of them here somewhere in the middle. And let's have a look at our page navigator, which is this one here. The page navigator actually is an easy way to get all pages inside a kind of navigation pane in here. Which means that if you select it, of course I can make this bigger if I want, I would see all my report pages in here. So I can simply control click, for instance on top 10 clients, control click here, and you see that I will navigate to this page. So it's an easier way, instead of creating manual buttons, so each button for each page of your report, you can simply use under the buttons the navigator and here the page navigator to put all your pages inside here, which you can then choose and select from. And also note that this navigator here, of course, is also customizable. So meaning if you select it first and then you take a look at the options here, you find similar options for the properties, titles, effects, and so on, which you've seen for the other buttons already. And if you go to the visual here, you can play around with other options. For instance, here with the shapes, you see that by default it's rectangle, but sometimes also, for instance, interesting could be the parallelogram. So if I select this one, then you see that now the shapes look a little bit different. So this might also be, of course, depend on your specific, let's say, a naming convention of your specific report pages, because if they are longer, then this might not be the best shape. But I just want to encourage you to try out the different shapes which are available in here, because there are a lot, and you can use those shapes for your navigation in here. You can also play around the corners. If I round the corners, you see that this looks different, the slant and so on, this looks different. So this is really something which means trial and error. There is no perfect setup, but as I said, feel free to try this out and see what you think is best and works best for you. And if you specified something and you don't like it, again, go to 3 dots and say revert all settings to default, and you get your default buttons back. Rotation is also available, so you can rotate the buttons like that and other options. I think the most interesting part here is next to the changing of the shapes, of course, that you can specify here whether you would like to have it horizontally as it is by default, or if you go to the grid layout here and say specify here as vertical. If you do this and you change the shape, let's drag it down, then you see that now the navigation is here from the top to the bottom. And this, of course, might look better depending on, again, your specific report design preferences, but I think here this might be a better option to have it here on the left side, for instance, and then use it here for navigation purposes. You can play around with padding here as well, but the main thing here from the grid layout is really the orientation. What's also interesting is if you go to the pages section here, you can specify whether you want to show hidden pages or not. So that means, for instance, DAX or no DAX here is currently hidden. Simply if you right click on a page, you can say, do you want to hide the page or not? So if I do the same for the customer classification here, and I say I want to hide the page, watch what happens in here for, or what happens here if we turn off then show hidden pages. So let's say I'd like to also hide this page as well. So now we have 2 hidden pages, DAX or no DAX, and customer classification. Currently they are turned on. This is why those 2 pages here are still visible. But if I say I want to turn it off, then you see that now those 2 pages are gone from the navigation pane. So also something you can customize here under pages. And the same is true for tooltip pages. However, this is something I will cover more extensively in the second course. But you see that it's pretty easy to do. Simply say whether you want to turn them on or off by clicking here, and you see that this navigation then changes. And as I said, there are various properties to change the style. As you can see here, there's also the state option, which you already covered, which means that you don't have to use the menu like that, static, but of course you can also say default here, if someone hovers over, for instance, one of those, what should happen? So if you go for the hover style, click on hover, then for instance you could say, then I'd like to see a different font color, let's say a blue font, and I also make it maybe bigger, so increase it maybe to, let's say here, something like bold, right? Which means that now if I hover over the pages, you see that now this looks even better, because here now my specific selection here on the hover is highlighted in bold, and in this case also in a different color, which makes it even more appealing to the report end consumer, at least from my point of view. But this is only, as I said, really basic, because there are so many things you can customize, and now I leave this up to you to figure out what's available and what you think is best. And if you have a certain recommendation for me as well, or for other people from the course, then please don't hesitate and write it inside the course resources in the course section, question and answers, okay? So thanks a lot. That's it for the buttons. Hopefully that was helpful. As always, Can't wait to see you in the next video. Until then, best guys. Hey friends, just wanted to say again, congratulations that you finished this part of the course, including all the DAX measures and also of course the report building. Now, this video is really for pure motivation, because I'm totally aware that sometimes people get a little bit discouraged because of DAX. And I'm also aware that, yes, it is true, DAX is not that easy to learn. And if someone tells you DAX in Power BI is totally easy, then he or she is lying to you. But you should never forget that with each new project, each new DAX formula you tackle, you learn more and you get better. And with time, you'll be an expert. Believe me. So just keep going and never give up. Hello and welcome back to this first video about the calculate function. Now this chapter deals with the most important function in DAX, and that's the so-called calculate function. Why is that? Because the calculate function has the power to change the filter context. What does this mean? Well, we will explore this during this chapter. At first, in this video, let's actually introduce our dataset. And we have a really easy dataset, but that's not the point. The main point is that this dataset helps us to understand step by step from scratch how the Power BI calculate function works. So let's dive into that. At first, I go under Excel. I click Excel here. You could also go in here, import from Excel the data. That also works. For me, I click up there and I'm using here this calculate introduction Excel file. You can download this from the resource section to follow along. So let's open this and let's see what the data looks like. Here we got the navigator window and we got actually two tables in here and also the sheets. Let's click on the sheet. Well, the sales sheet, quite easy. We got a product ID here and we got sales figures here. And the product sheet is also very easy. We got a product ID, a product name. In this case, these are energy drinks, and we got a price and a cost attached to it. So basically, we are able to connect the product and the sales table based on the product ID. And the same is true, of course, here for the tables. So they contain exactly the same data. There's no difference in here. So as best practice, I personally always prefer to import the tables. So I can go with the table and select those two. And then I go to transform data just to have a look what this data actually looks like. And here we go. We got our query window and we see we got the product ID, the sales, and we can also check the product types here, the data types quite quickly. I think that's best practice. Always make sure that you got the right types here as an example, numbers. And if I go to my product table here, I can see product ID is also a number here. So when we want to join based on the same column, then the data type should match. That's fine. And also product name, price and cost, that also looks fine to me for now. If you want, you can also rename here your table structure. For instance, you could say instead of product TBL, it could be only products, and sales could be sales. That's up to you if you want to define this or not. Simply go in here and rename it if you want. Or also here, you can also rename it here. If you right click, and the option here is also an option to rename. So that's fine. So let's actually click on close and apply, because the data itself looks fine. Just as best practice, always make sure that you check the data you import, and in case you need, just change it. For instance, the data type and other things. Okay, so we got our two tables up there, and let's actually quickly check the relationship window, because that's important. If we go to the model here, the model view, we see that, let me just upgrade now. So depending on the Power BI version, you probably see this immediately. For me, I had to upgrade to the new view, but then it looks like that. And I can see my tables here. I got a product table here and the sales table here. And I also got the connection from the one side to the many side. So one to star. This is exactly what I would expect, because hopefully we have one product which has been sold multiple times. And Power BI was smart enough to pick up the relationship if you hover over it, even though there's a little spelling mistake. Maybe you can see that. The product ID is here with a space and here it's without a space, but here Power BI is smart enough to detect the relationship. Otherwise we would have to find it ourselves. But that's fine. Other things I don't want to change now in the model view. The only thing is that the relationship is set up correctly. That's important. And now let's actually go to the report view here, and let's actually create a easy visual. Let's say a table in here. I go in my, let's say here with the sales table, that's actually fine. I have my product ID, but actually I would like to see the product name. So I go on the products table, take the product name just to get my table structure here. And then I also would like to see the sales numbers. So I can tick the sales option here. And by default, then I would see the sales for each of the products. And maybe that's a little bit too small for you. So let me go in here and just change here the values just to make them a little bigger. Go down here and say, for instance, for the text size, let's say 15. Hopefully that's big enough on your screen. So quite easy so far, I know, but don't worry. So what else can we do? Well, we could also add a measure here, and we'll do this in a minute, but important here is the following. Because we set up the relationship structure here, and it's also important to understand how calculate works later on. We set up a relationship here between the two tables based on a specific field. Because we did that, then Power BI was smart enough actually to connect here the two tables and also figure out the correct sales numbers. So matching basically the product name from the products table to the sales of the product from the sales table. And we got 40, 50, and so on. So that's done automatically for us. Because it's a numerical column, Power BI is summing this up automatically. And if we create a measure on our own, we can do that. So if I right click here on my sales table and say I'd like to create a measure, click on this option here, then you can do that. And you can see here, text separated. Let me dismiss this for now. And let's go inside here and let me zoom in so you can see that better. So for a measure, I could say my total sales as an example. So total sales is equal to, and then I simply say the sum, it's a sum function, and then I can give it a column name. In this case, I'm referring to the sales. So using the sales name, so the sales table, and then in this table, the sales column. I can close this, I can press enter. So far, so good. Then I zoom out here and go in my table back again here. And then I also want to use the total sales measure, which we have created here. And we can see we got exactly the same numbers here. So these numbers basically are calculated based on the filter context. That's one important keyword, and we dive deeper into that in the next couple of videos. But in this here, in this visual, and the same is true for all the other visuals you create. So may it be a bar chart, a pie chart, whatever you want. But each visual always has a filter context. And this filter context, in this case, is each row in the table. So we can see 40 here for Monster Energy, because Monster Energy here filters the sales table to all the rows of Monster Energy, and this is in total 40. And you can easily check this if you go to the data view here, and that is why I used here this really easy table, because it's much easier to understand. So here, for instance, for Monster, we can see that the product ID is 1. So because we know that, we can take a look at the sales table, go to the sales table, and we can see we got product IDs here. And if I select here, basically I do the filtering. Remember the keyword filter context. I filter my data to product ID number 1. And if I click OK, then I get entries like 5, 25, and 10. These are the entries for Monster. And because we got in sum 40, so 5 plus 25, plus 10. And if we go back to the view, we can see these are exactly 40. And the same is true for all the other energy drinks in this case. So basically this filtering here, that's been done automatically because of the filter context which gets applied based on the visual we have. And in our case, this is only the product name. If you would have additional columns, like for instance a country and the product name, then the filter context of course would expand, and we would have the filter context country name as well as product. And the data would get filtered based on the combination of those two fields, and so on. But that's the main idea how the filter context works. Okay? So I know this was a pretty easy start, but believe me, it's really a good way to start this way, and we're gonna do it now from scratch, step by step, going through the calculate function and how it works. So see you in the next video. Until then. Hello and welcome back to the next video. And now let's dive a little bit deeper into the various contexts which are available in Power BI. In the last video we learned about the filter context already. However, we need to be a little bit more specific about that, because actually there are two filter contexts in Power BI. There's a so-called internal filter context and there's an external filter context. What we see here and what we talked about in the first video, so all these names as a product name here in our simple table, is the so-called external filter context. The internal filter context will be relevant when we're using the calculate function. So let's explore that actually. Let's create a measure for only the sales of, let's say, Red Bull. We can do that. We create a new measure. I right click on my table here and say I'd like to create a new measure. And then let's see, just a second, there's our measure. And let's call this maybe sales, or let's say total sales Red Bull. Total sales Red Bull as an example. It's equal to, and now let me just make it a little bigger. So total sales Red Bull. And now we use the calculate function. So we say calculate, and let's just see what it does. It evaluates an expression in a context modified by filters. So here you can see that better. And that's exactly the key point here. So modified by filters. So the calculate function allows us to evaluate any kind of expression. In our example, our total sales, but you could use any kind of expression. So let's go with the total sales for now, because this is a measure we have. We select it, and now we can give it a filter here. And this filter can be anything. So in our case, we say we would like to make sure that the product name, in our case, so the product name, this one here, is equal to Red Bull. Red Bull. And this is case sensitive, so you need to spell it exactly as it's spelled in the table itself. So that's fine. And let me close this now, and we are good to go. So we basically modify the expression, which is total sales, by this new filter, which is simply that we say we only want to see the sales for Red Bull. So let's press enter, and let's create the measure. Here we go. And now let's actually evaluate that. So maybe create a simple card icon. We go with the card, and let's visualize that. If I tick the total sales Red Bull, then we see we get 50 in here. And this is exactly what we would expect, right? Because if I take a look at the table, I can see Red Bull, and the sales are actually 50, the total sales here as well. So that's fine. However, the point is, a card visual itself has no context, so it has no filter applied, right? That is why, as an example, if I use another card, if I take a card and add the total sales number, I would see 148, which is simply the total for all the sales, because there's no filter applied. Like in a table, we have a row filter here applied. So sorry, we have a filter applied, yes, for each rows in the table here. But for a card, by default, we don't have any filter. So that is why what happens, let's figure that out, what happens if we add the new measure we have created, where we said we only want to see sales for Red Bull. What happens if we add this to our table? So let's select the table first, and then tick the total sales Red Bull. So add it to the table. You can also drag it inside if you want. If I tick it now, I will see that I got 50 for each product. Why is that? Well, the reason is because of the two filter contexts which exist. As I said before, we got an external filter context in Power BI, and we also get, when we use the calculate function, an internal filter context. So the external filter context in this case is coming here from the different product names we have in our table. So Monster Red Bull, Monster Energy, Red Bull, Relentless, and Rockstar, all these are external filter contexts which filter the data to show the correct sales numbers. However, if we create a function like we have done here using calculate, so a DAX expression like this one we have created, then what happens is we create a so-called internal filter context as well. This internal filter context is exactly what we specify here. So the additional arguments we give the calculate function. And this internal filter context is ranked higher than the external filter context. That means Power BI is evaluating both contexts, so the external ones from the table, as well as the internal one from our measure here. And if the internal one, like this one, differs from the external one, which we have in the table, then the internal one overrides the external one. That means only this one in the calculate function gets applied, and the other one, which in this case would be Monster Energy, simply gets overridden. So it will not be taken into account anymore. For Red Bull, the same is true, but here you might also say it intersects. That's true, but I like to think always that the internal filter context is more powerful than the external, and whatever we specify within the calculate function as an internal filter context will override the external filter context. That's how I think about it. So, next to the calculate function, which allows us to modify expressions, so expressions is referring to measures, we can also use the calculate table function. The calculate table function is kind of similar to calculate function, however, it can only be used as a table. So that means that calculate table as a DAX expression always returns a table. Calculate, on the other hand, always returns a modified measure. We can easily spot this as an example if I go under right-click on the sales table as an example and create a new measure here, new measure. And here I would try to use calculate table. So if I would specify calculate table Red Bull, just as an example, equals. And now I want to use the calculate table function when I create a measure. Keep this in mind. We checked measure and we create a measure. Now I select calculate table in here. What does this do? It evaluates a table expression in a context modified by filters. So kind of similar the expression, or the here, but it says a table expression, and that is the key here. So if you give it a table, you see that the first argument is a table. It's not an expression. So the table could be the sales table, so sales TBL, and then the filter could be that here in this case the product, we can search for that the product name is equal to Red Bull. So it's kind of similar as before, but this time it's a calculate table expression. Now if I try to evaluate that, I will get an error. So if I press enter, you see that here the expression refers to multiple columns. Multiple columns cannot be converted to a scalar value. So a scalar value, meaning an expression, can only be returned by the calculate function, but not by the calculate table function. The calculate table returns a table. That is why we can't use it like that. What we could do, if we want, is we can select all of this, or actually everything, Control C to copy it. Then I press escape to remove this because the measure won't work. Let me also right click here and say I want to actually delete this from model. I don't need it. Yes, delete. And then instead what we can do if we want is we can say, instead of creating a new measure here, we could say we would like to create a new table. You can see here, write a DAX expression, creating a new table. If we take this option, and then let me paste this again inside. Here we also use the calculate table function, but this time we create a complete new table. And that's fine. So if I press enter, as an example here, you'll see that here a new table gets created up there. It's also appearing here, and we don't have any issues here. And if we want to take a look at the table, we can simply go to the data view. Let me tick this option here, and let's actually explore that. Click on it, and you'll see that the table is simply a subset of our original sales table, but only contains products with the product ID number 2. And if I go to my product table just to check that, I will see that the product ID number 2 is Red Bull. So calculate table allows us basically to return a table, but modified by specific filters we have applied. In our case, simply product name equals Red Bull. So calculate and calculate table behave similar. The main difference is that calculate table always returns a table, and calculate returns a scalar value. So basically some kind of measure, some kind of expression like total sales, for instance, in a modified context. This is true for both of them. Okay, so far so good. Now we talked about the internal and external filter context, and also about calculate function as well as the calculate table function and what they can do for us. Now let's actually dive a little bit more in other important concepts, which is the row context as well as the context transition, the second part. So internal and external filter context are relevant to calculate. However, next to filter context, there's also a so-called row context in Power BI. And let's actually evaluate that. Let's go to our data view or model view here. Let's go to our data view, click the data view here, and let's go to our original sales table again. So let me first remove this filter. This is the one we have applied before. Let's actually clear this filter just to see our whole table again. So the row context, in this case, in Power BI, simply is referring, when we take a look at the table, to each row in the table. So this is true for all the tables in our model. There's always a row context attached to it. In this case, the row context only contains actually of product ID and the sales number here, but the sales number here is simply defined by each row. And if there would be additional additional columns, then of course they would also flow into the row context. So row context, think of it like each row in a table has a specific context, and that is why you can see a sales number in here. Now, what if we would apply now our measure, like the first one, total sales, which we have created, which is the sum of the sales. What if we would add this to our table? Let's figure that out. Let's go to the table tools here and say, here we would like to create a new column. Click this option here, and then let's see, here's the column. And for the column, let me actually simply specify exactly the same. Let's say total sales column, just name it this way, and say it's equal to sum of, in this case, the sales. Sales table sales. So basically, we simply want the sum of this column in here. And I hope you can see that. Otherwise, let me zoom in. But the formula is exactly the same as we had before. So that's fine. And now if I press enter, what do we get? Well, we got 148 for each of the rows. Why is that? Well, the problem here is that we currently have row context applied here, but no context transition is happening. That means the idea or concept behind context transition is that each row, which serves as a filter, is transformed into a filter context, so to evaluate this properly. This is context transition. So context transition means use the row context, which is available for each row, and transform this or transfer this into a filter context. By default, if you use any kind of expression like this, this will not work. And this is where also the calculate function comes into play. Because if I do the same, but using the calculate function, let's check that out. You'll see what I mean. Let me just create a new column, go to table here and say I'd like to create a new column. Click this option here. And let's call this maybe calculate total sales column. So calculate total sales column. And I know the names are terrible, but don't worry. Just as an expression here. I will delete those later on. So calculate total sales column is equal to, and the only thing which I do different now is I use the calculate function. So I say calculate, and then again I say the sum of my, in this case, sales, from the sales table to sales column. And then I close the sum function and also close the calculate function. So basically I do exactly the same as in this column here, but this time I wrap it in the calculate function. And what do you think what happens now? So let's explore that. Let me press enter. And you see we got the correct values. So we got 10, 20, 25, and so on. So these are exactly the same values as we have here in the sales column. And this is probably what you would expect actually as a return. So why does this work using the calculate function here? We get the correct numbers here. But when we actually do not use the calculate function, only the sum function here, we get the total amount. So basically the sum of the whole column. Why is that? And the reason is the so-called, what I mentioned before, context transition. So what the calculate function can do for us here, and that's also why the function is so powerful, it allows to evaluate row context, so basically the context for each row, and it transforms this context into a filter context. That means that here, for the first row, product ID 1 and sales 10, so this basically here is the context, and this context gets evaluated and pasted into a filter context, so you got 10 here back. Because each of those rows is unique. You don't see any duplicates here, because even if the product ID is 1 here and 1 here, you see a product ID here, 1 here and sales 10, and here you can see a product ID 1 and sales 25. So each of the row combination here is different. Each of them is unique, and that is why if we apply now the row context and it gets transformed into a filter context, then we can see the correct values in here using the calculate function. This context transition is available with calculate, and there's one additional feature which also will work, which are measures. So let's actually try that out. And this is interesting. So let's go with our total sales. We created a measure here, which is simply the sum of sales table sales, right? So if I take a look at the column we have created, the total sales column, if I take this option, you see this was also simply the sum of the sales table. So basically the formula for the column here is exactly the same as for the measure total sales we have created. So let me actually remove this column now, and also the other one, because we don't need it anymore. It was just for demonstration purposes. I delete this one. Yes, I would like to delete it. I go to the second one, right click here, and I say delete it. Okay. So that also only the product ID and the sales remain. And now let's actually add a new column. So let's say new column here. And let's call this, again, total sales column. Spell it correctly, column is equal to. And what I will do now is I will refer to the measure we have created. So total sales. So instead of typing sum sales table and then total sales, which we had before, right? This one, what we did, I will simply use the measure itself, which actually contains exactly the same formula. So let's say total, and here we go, total sales. And what do you expect now? What do you think what happens? So let's find out. Let me press enter here. And we see we got the correct values. Why is that? Why do we get the correct values when we are referring to a measure here, which actually, the total sales here, is the same as when we create a calculate column and put the same formula inside. But when we use the column with this formula, we get the total amount for the specific column, so 148. And if we're referring to the measure, as we do here, then we get the correct numbers. Why is that? And the reason for this is, again, context transition. Because what this total sales measure actually is nothing more than this formula we had before, this one here, wrapped in a calculate function. So each measure, you can think of it like that. Each measure you create, like this one here, sum of the sales table, sales, total sales, is automatically converted into a calculate. Calculate sum of sales table, sales. So that happens automatically when you create a measure. And you're referring to this measure then in a column here as an instance. Then the calculate gets automatically applied, and that is why this works. Okay? So this behavior you have seen here, that basically the right formula gets applied here, and you can see basically the correct numbers. This is so-called context transition. And this is something which is available in Power BI based on the calculate function. So that is why this function is so powerful. So that's it actually for this video. So now you know a lot more about different kinds of evaluation contexts. So there's a filter context, there's an internal filter context and an external filter context, which we've seen here. So by default, from the visual itself, you have an external filter context with the calculate function, which we applied for the Red Bull sales. There's in this case, an internal filter context. When the external and the internal filter context collide, then always the internal filter context overrides the external filter context, in this case Red Bull, and that is why we have seen the 15 here. We also took a look at each row, so based on all the tables you have in the model, each table always has a row context, and this row context can be modified into a filter context using the calculate function, and that's called context transition. Okay? So that's it. Hopefully you enjoyed the video. Hopefully you understood what we did. In case you got any questions, feel free to ask. Otherwise, I'll hopefully see you in the next video. Until then, best guys. Hello and welcome back to the next video about calculate. Now in the last video we talked about the various contexts in Power BI for calculate. So we talked about the internal and the external filter context. Remember, the external filter context always comes from the visual directly, in our case our table. The internal filter context is the context applied by the calculate function. We also talked about row context as well as the context transition, which happens when you apply calculate, as well as with measures implicitly. So let's actually dive a little bit deeper into two additional functions which also are often applied with calculate, which is the all function as well as the values function. Now, for this expression we created here, the total sales Red Bull, if you remember, we said that we want to apply or basically calculate the total sales, but on a filtered table, and this table was actually filtered to the product name Red Bull. Now we can get the same result in a different way. So let's explore that. Let me first right click on the sales table here and create a new measure. Okay, here we go. And then for this measure here, I'd like to call this, let's say, total sales all Red Bull. Okay, Red Bull, just as an example here. And the idea is now that we want to apply the calculate function one more time. We need to give it an expression. So let's say, in our case, the total sales again. And then here we need to apply a filter. Now we use now the filter function. The filter function, if you use it here, you see it returns a table that has been filtered. So far so good. The important concept here is that it returns a table. And that is actually true always when you use the calculate function. you want to evaluate an expression and the second argument, so on the third and so on, no matter how many parts you use here for the filter expressions. But these expressions here, like filter 1, filter 2, and so on, those will always return tables. That is important, okay? So the filter function can return a table, which is filtered. So in our case, we can give it a table. Now, to remove any of the external filter contexts, like monster, Red Bull, relentless, and so on, we're going to use the all function. So all here returns all the rows in the table or all the values in the column, ignoring any filters. Important, it ignores any filters. That means it removes the external filters. So monster, Red Bull, and so on. So that's why we're going to use all. Then we can give it a table. In our case, we are referring to the product table. Okay. And then as a filter expression, we say that the product name, so let's go to the product name of the product table, should be equal to, in quotes, Red Bull, as an example. And by the way, this would also work with other energy drinks. Okay. So let me close this parenthesis here. And then actually also close the calculate function for now. Okay, so I press enter to evaluate the formula. And let's just see if we click inside our table to apply the formula. Let's just see what results do we get. Well, total sales or Red Bull. I tick this option here and you see we get exactly the same results as we have here. So that just means that this expression we have created here, so the total sales or Red Bull, this is just a longer form for if we use the abbreviation, which is this one, product name equals Red Bull directly. So basically what Power BI does under the hood is actually transforming this expression here into this expression. But this is happening automatically, so you don't need to write the longer formula. We can use the shorter formula if you want. But that's basically what happens. And here the all function, again, removes all external filter context, and then this will actually be applied. And the way calculate works is actually, as I said, this returns a table. This table is the complete product table, but filtered to the product name Red Bull. And this filtered table will be the new evaluation context, on which this measure, in this case total sales, is evaluated, and then the result is returned, removing what has been applied externally. Okay? So that's the order of operation. First, calculate evaluates what's in here, so the various tables, you give it as filters, and then it evaluates the expression based on this filter table you give it. And then the result is returned. Okay, so far so good. So sometimes, why could this be useful actually, using this all function, or basically removing the filters here? Well, let's just think about it. What if we would like to know what is basically the percentage of sales, for instance, for a specific product in comparison to another product? So in this case, if we're referring to Red Bull, we could be interested, okay, what is the amount of Monster sales in regards to, or as a comparison to, Red Bull sales, as an example. So that is why we could simply now use an additional measure here. You can right-click on the sales table, create a new measure, and say, for us now, we'd simply like to divide two measures. So let's say percentage of Red Bull sales. And we simply say we want to divide the total sales, so total sales, and then simply divide it by a slash using either the total sales Red Bull or the total sales all Red Bull. Because they return the same result, it would not matter, would not make any difference. So I can say total sales, and then let's go Red Bull here for now. I press enter, and we have created our measure. And one thing I like to do immediately is simply click the percentage symbol here, tick this option here just to make sure that it shows a percentage number. You can adjust here the number of decimals if you want. But then if we simply take a look what this results, tick this option here, and we would see here percentage numbers, right? And Red Bull, of course, would be 100% of the same. But for instance, Monster would be less sold, or the sales amount would be less 80% of Red Bull sales, as an example here. There are two things I'd like to mention here. The first thing is that the calculation we currently do, so based the total sales divided by total sales Red Bull, is not best practice. What is best practice is actually using the so-called divide function. And you see why that is if we simply, let me just adjust this measure for now. Let's call the divide function. divide. Here we go. And you can see it's saved divide function with the ability to handle divide by zero case. And that's exactly the point. If you use total sales and then the slash divided by any other measure. Now it could be the case for whatever reason that the second, so basically the numerator, would be 0. And then Power BI of course would return an error. And to avoid this by default, you simply use the divide function and say divide, and then the numerator, this one, and the denominator, which is the second one, in this case, let's say total sales, Red Bull again, so this one here, and then you can even specify an alternate result. So just in case the denominator is 0, right, you would get you would not get actually the divided by 0 error. Instead, you can refer to another result, like there's an issue with denominator or anything else you want. You can specify anything. Even you can specify text and put it in this case in quotes if you want. For me now, I don't need to do anything. I simply close parentheses. But just wanted to show you that you can do it. And this basically is best practice using divide function. So let's actually do it this way. And let's take a look at what we've created here. And you can see we got exactly the same results in here. Now a question which often arises is that here, for instance, for the total figure, right? We can see here 296, which in this case would be true because we would divide the total amount, 148, by 50. That is true. But sometimes people don't like to see this at the total level. They just want to have a blank here. They don't want to see the 296. How can we avoid this? Well, there are various ways in Power BI to do it, but one way would be to combine the if condition with the has1value function. So the idea is that we simply check whether we currently have one specific value, in our case for our product name. Because for each row in a table, in our example, and this would be true for instance, a bar chart as well, as long as you have a bar chart, or in this case one row in our table for a specific product, then the has1value function for the product would return true. On the total area here, so on this row, they would not one specific product. So has1value would return false for this row, the total row. And that is why we can use it. So if we go inside here and say, let's check that. Let's say if, and now parenthesis, has1value. Okay, we'll use this function here for now. And then I'm referring to the product name. So go with, take this option, product name. Here we go. So if the product name has one value, let me close this here. Then as a result, if true, I want to do the divide function. And if not, if this return is false, then I simply want to return blank. Blank simply means we don't return anything, like that. And of course you can make this a little bit nicer. So if I press Shift Enter, I can go to new line and then do my calculation formula in here. Okay, just to formulate it correctly. So, okay, now we have the expression itself. So here we go, has one value. We check this, whether that's true or not. And if there's not only one specific product name in the visualization, then we want to return blank. Otherwise, if there's one product, then divide it, okay? And if we do it this way, let me close this, make this smaller. Let's actually evaluate that. If I press enter, watch what happens with the 296. If I press enter now, you'll see that now they are gone in here, right? So that's how you can avoid to show this at the total line, if you want to do that. So it's one option to do it. And as I said, there are various other options. Like you've seen, maybe there is a has1filter function. It's also available for you, and other functions. But that's just one option here, has1value, in combination with the if condition. So finally, as I mentioned at the beginning, I'd like to also show you another combination which is often used, which is instead of using the all function, using the values function in Power BI in combination with calculate. And let's see what the difference actually is. Remember, with the total sales all, in this case this one here, so that's the product name is equal to Red Bull. And again, here we could also press Shift Enter and go to new line if we want to do that, just to make it a little bit easier to read. But press enter. What we did actually here was we used the all function, and it returned 50, so Red Bull everywhere, because it used this new internal filter context to override the external filter context. Now let's do something kind of similar. We use the same formula, but this time instead of using all, we will use the values function. And just to save a little bit of time for us, what I do is I simply take everything here and I Control C to copy it, and then I right click on my sales table to create a new measure, and then I paste this inside, like that. And of course I need to rename the measure because I can't use the same name twice. And also it's not referring to all function, it's referring to the values function. That's what I type in values here. So, and the only thing we need to adjust now is referring to values instead of all. Here we go. And you see, that's always a good idea to read through that. Even sometimes it's not so easy to understand, but still it helps often. So when a column name is given, returns a single column table or of unique values. When a table name is given, returns a table with the same columns. So remember, here we give it a table name, product name, so actually the second part here is interesting to us. So we give it a table and returns a table with the same columns. So we basically get a unique list of all the values in this specific product table. That's what it actually tells us. So it removes the duplicates, if you want to call it this way. So here we go. And now if I press enter, so everything else is the same. So let's actually explore what this did for us. And what do you think? You can pause the video if you want, but I will show you the result now. If I tick this option here, what we basically get is only one value in here. So why is that? The reason is that the values function itself does not behave like the all function. The all function returns all the external filter context here and simply applies only the internal filter context. That is why we only see Red Bull everywhere. This is not true for the values function, as you can see here, because the values function actually takes both of the contexts into account. And that is why you only see, basically here, value for Red Bull. So if this is the behavior you want, then you would go with the values function. If you don't want to see any other values for the other columns, you see, you can do that easily by using or applying values. If you, on the other hand, want to see the same result everywhere, like here for Red Bull as an instance, then you would go with the all function. Okay? So that is the main difference between those two. And both of those functions are often applied in combination with calculate. That's why it's important to understand the difference and also see it. So that's it for this video. So hopefully you understood what we did. If you got questions, feel free to ask. Otherwise, thanks for watching, and I can't wait to see you in the next video. Until then, best guys.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hey friends, welcome back. Now in the last video we have seen various options how we can apply all as well as values in combination with the calculate function. However, if I take a look at our total sales value function here, it actually is kind of static, right? Because what we did was we specified here a product table, in this case the product name, and we set it to Red Bull. And this of course is static. That is why, as an example, here we would always see the 50 and here also we'd always see the 50. Now what if we would like to make this a little bit more dynamic? So instead of having always Red Bull, we would actually have the option to, well, apply any kind of selection, and based on our selection, this would return the values for Monster, Red Bull, Relentless, or Rockstar. Or of course if you have different values in your specific table, then of course those values. So how can we do that? Well, there's an option to apply the values function a little bit differently. So instead of using values here with calculate, let's actually create a table based on values. Remember what values did. It returns a table of a unique list, so without duplicates, of a specific column. So let's do that. Let's say I would like to see a unique list from my product table of the product names. So in my case, the energy drinks. I can simply go under, in this case, we go to modeling here, and say under modeling, I'd like to create a new table because I want to create it with a DAX expression. So I take this option here, and just a second, here we go, there's the table. And this table will be my product names TBL, okay, equal to, and I will use the values function one more time, but this time I'm referring to, for my values, I'm referring to the product table, and for the product table itself, the product name. If I do that, what this does is basically it creates a new table in our dataset here. And this table will be simply a unique list, so our duplicates of product names. If I press enter, let's just see. And there is our product names table created. And we can have a look if we want. Simply go to the data view, take this option here, and then select your product names table, and you see that's basically what it contains. So a pretty easy table, simply a unique list of all the product names. That's what values does. So then we can use this new table as our filter table. So I could say I'm using my, in this case, the product name table, this one here, and let me select it first. Okay, there's my table. And now I can make a slicer of that. So that's why I'm choosing here to switch from table to a slicer visual, take the slicer option, and then I have my unique list of product names here, which I can select like that, that, and so on, right? Okay, so let me actually maybe make this a little bit bigger so you can see that better. So go with the item section here of the slicer in the formatting options, and let's say the text size, let's set this maybe to 15, right? One more, 15. Okay, now it's a little bigger. And sometimes you don't like actually this view. What I often prefer is if I go under the general section of a slicer, I always have the option here to change the orientation. And if you switch from vertical to horizontal, like that, you see that now you got these boxes, which you can format further. Of course, you can change the outline color as well as the fill color or the color of the font and so on. But I personally prefer oftentimes this kind of filter. It looks a little bit more appealing to me. Okay, so here we got our filter. So far so good. And now, as you've seen already, if I select something, well, that's good, but actually nothing happens, right? So I've selected Monster Energy here, but I still see here, as an example, the value for Red Bull. The same is true for the all function, by the way, right? Because we hard-coded the value in the formula. So that's why we first need to get actually the selection we do here. And before we actually create the measure, let's actually take a little bit of time and explore here in the model view what this table actually, or how the table is actually now currently related to the model we have. So here you see the new table which we've created, and here I need to go to the right a little bit. There it is. This new table has currently no relationship, right, to our model. That's important. Okay, we don't want to have any relationship. We don't need it because we want to create a measure which allows us basically then to do the filtering, even though we don't have any relationship. But I just wanted to point this out here. So the product name has no relation, and that is also why we can tick anything here, but nothing will happen, okay? We don't see here a filtered now to Monster Energy, for instance, because we don't have any relationship. Okay, so how can we get now this value here, which we select? Well, there's a function in Power BI, which is a so-called selected value function, which can give us exactly this result. So if I go back to my table, in this case I'm going with this one here, that's fine, and I right click here and go to the measures table. So let me select it for now, create the measure in this table. We can move this later on in any kind of table, or also in a measures table if we want to do that, but for now let's stick it here, okay? Now this measure is simply the, let's say, selected product. And now this is equal to the selected value function. There it is. Selected, where is it? I need to spell selected value. Here we go. Now here, returns the value when there's only one value in the specified column, otherwise returns the alternate result. So if we tick this option, press the tab key here, we can give it a column name, and this is optional because it's in brackets here, an alternate result. So if I'm referring to the column name, I could refer to from my product names table, which we created. So product names table, I would like to see the product name itself, okay? So that's the table we have created with the values function. So let me close this for now. And if I press enter, we can simply see what this selected product will return. So let me actually tick this option here. And then instead of a bar chart, I actually, because it's a text, let me switch this maybe to a card visual. Take the card option here, and currently we see blank. Now why is that? Because we haven't made any selection, right? So if you tick as an example, Monster Energy here, you'll see that now we see Monster Energy. If I tick Red Bull, I would get Red Bull, and so on. So now this selected value function actually returns the specific value which is selected by the product name. And remember, it only returns a value if there's only one product selected. So if you select more than one product, if I hold my control key and click on Monster Energy as well, now I've selected two of them, now it returns blank again, because it only returns a value if there's one selected. If you don't want to see the blank, of course you can easily change this. Let me go back to Monster here, select this option here, and go to our measure, this one, because remember there was an alternate result. So I could use a comma here, and as an alternate result, I can specify, for instance, Red Bull, if I want to use this as my default value. And now if I press enter, so press enter here for the formula, now you would see Red Bull as default. So whenever there is, let me click relentless, I can see relentless, but now if I remove my filter, if I deselect it, you'll see it's Red Bull. So even though I don't have selected anything, the default selection now is Red Bull. So if you want to have anything default, you can specify this in the alternate result. And now you avoid actually returning blank. So we got this as well. Let me make this maybe a little smaller here. Okay, here we got our card. And this measure, which we created here, the selected value product name, this one. So here we go, this one here. Now this can be used instead of the static value which we have applied. So all we do now is we go back to our, in this case was the sales table where we create all our measures so far. And now if I'm referring to my total sales values as an example, so this one, which we have created with the filter values function, where we specified a hard-coded value here for Red Bull, instead of using this Red Bull as a hard-coded value, we're simply referring to our selected product, which we used here. So instead of actually changing it here, I will simply copy this formula, okay? Copy it. You can write it again if you want, but in this case, let's be a little bit more efficient. I right click here, I go to new measure, and then I paste this inside. And this time I say total sales values selected. Okay, that's what I name it. Let's call this selected. And then we say filter values, that's fine. But now for the product table, product name is not equal to Red Bull. It's simply the selected value, basically what we return here. So we can simply say selected, and there, down there, there's the calculator icon, which is referring to the measure selected product. We can tick this option here, and then let's actually press enter to apply this formula. So we don't get any errors, so far so good. And now we can also put this inside, so maybe make this table even a little bit bigger, and select now the total sales values here, selected. I tick this option here, and right now we also see it's 50, so it's the same as we had before. But if we now change something from the product name, let's take this Monster Energy, watch what happens with our 50, it's now more dynamic. I can tick this option, and now I can see here it's 40, right? And if I click on Relentless, then it would be 25, and so on. So now this jumps and adjusts based on the selection we have done. So this works for this values function, so instead of having it hard-coded here or fixed, we simply make it more dynamic. And the same is true, of course, if we would now replace this in the total sales Red Bull, which we have created. Remember, as an example, we went here, for instance, for the all function. It's exactly the same. You just have to now change this hard-coded value here to the selection you made here, just to make it more dynamic. Okay? So that's a little excursus, but I think that's important and interesting. So if you apply this out yourself, try it out. And as always, thanks so much for watching, and hopefully see you in the next video. Until then, best guys. Hello and welcome back. Now let's explore how we can use the calculate function using multiple criteria. So let's say we would like to evaluate the total sales numbers, but only for rows in our dataset where the sales are between 15 and 25, as an example. So that would mean that we need to go to our table, this one, in this case the sales table, let me select it first, and then we need to apply a kind of, in this case, numeric filter. So if I go to my sales column here, as an example, I tick this option, and under number filters, I would like to apply something which is, in this case, greater than, and as well as less than. So let's say greater than. And here is greater than, and then I say it should be greater than 15. Oh, so specify 15 here. And at the same time, that's why we use an and condition here, say is less than, let's say is less than, and then let's say 25 as an example, right? So, or let's actually specify greater or equal, let's say greater or equal to, just to include the 15, 25 in here, and say less than or equal to, in this case, 25, okay? So that means we want to filter our data set, and we only want to keep values in between 15 and 25. If I click OK, now you see that the table gets filtered here, and we see a little less data. As an example here, for product ID number 2, we see 20. For product ID number 1, we see 25. And for product ID number 3, we see 18 plus 15 is 33. And for 4, we see 15. Now let's actually check that in the measure with the calculate function. So let's say we'd like to create a new measure here. I right click on the sales table and say new measure in here. And we can simply name this measure properly. Let's just say this is our sales between, now say 15 and 25, okay? Just as an example. And then say it's equal to, and I'm referring to the calculate function. So let me just increase the size even bigger. Okay, calculate function. And now the expression itself is, again, our total sales. So in our case, it's total sales. And now we need to give it the filter expression. And in our case, it's from the sales table, the sales column. So sales table, sales column. Here, this one here should be greater or equal to 15. And at the same time, and here we can use the double ampersand symbol. So twice here, we want to ensure that the sales table, and again referring to the from the sales table, the sales column, so this one here should be at the same time less or equal to 25. 5, not 6. Close the parenthesis, and we're basically good to go. Let me maybe put here, go to Shift Enter, just add it to a new line. And that's it, okay? So we can refer to multiple filter criteria here using this double ampersand symbol. And let's evaluate that. Let's press Enter to see, create the measure itself. Just a second, here we go. And now let's actually go to our table. And maybe let me just remove a few lines from our table which we don't need, just to make it a little bit smaller again. And now let's actually evaluate what we have created. Our total sales between, or with values between, we make this bigger, 15 and 25. Here we go, this one. Select the table first, click on the measure here, and now you see basically here's the result, okay? So it's 93 instead of the 148, the whole table, and we can see here the values. And remember, as just an example, if we take a look at our dataset, for instance, Rockstar here, just to check that, is currently 33, and Red Bull is now only 20 instead of 50. So if we go back to our table, and here is still the filter table because we applied the numeric filter. For Red Bull, which is in this case ID number 2, we can see 20. And for Rockstar, which is product ID number 3, we can see 18 plus 15, which is exactly the 33 which you see here. And just by the way, if you don't remember the product ID, so that 2, for instance, is Red Bull, and that 3 is a Rockstar, all you need to do is go back to the product table, and here you can see 2 is Red Bull, and 3 is Rockstar. So you can easily check that. Okay? And that's basically how you can filter the data and only return results between the thresholds you have set here. The same formula can also be built using the AND function. So as we have in Excel as an example, we also have in Power BI the AND function. So the first example was referring to this double ampersand, which we had here, this one. But we can do this differently as well. Let me just copy all of this. Of course, you can also rewrite it, but let's actually copy it just to be a little bit faster. Let's right click on the table, go to new measure here, and just paste this inside. Just a second, here we go, paste it inside. And now let's say sales between 15 and 25. And so version 2. So here we go, and say calculate total sales. And now instead of using this with the ampersand symbol, we simply type in the AND function. So AND here, and checks whether all arguments are true and returns true if all arguments are true. Okay, so we can simply check here and then we say the sales table sales should be greater or equal to 15. And then as a second argument, we need to remove the double ampersand. Instead, we simply use a comma here for second logic. Okay, just to make sure that both of them are correct. And then we close here the AND function. And finally, of course, we need to also close the calculate function. So we need a second parenthesis here. Okay, so far so good. Let's press enter just to make sure that we really get the results which we would expect. And if I take the table one more time, and now we say we would also like to see the sales between 15 and 25 in the second version. So press this option here, and then you see if I make this bigger, we get exactly the same results that we had here, right? So both these options are valid, and it's up to you whether you want to use here the double ampersand, or in our case, because it's the same here, you can also refer to the AND function and get exactly the same result. But this would allow you to use the AND formula and basically use multiple criteria to filter your dataset, okay? So that's it for this video. Hopefully you understood what we did. In case you got questions, feel free to ask. Otherwise, I can't wait to see you in the next video. Until then, best guys. Hello and welcome back, friends. Now, in the last video we explored multiple criteria using the AND formula, But of course, sometimes it might be the case that you only want to check whether one condition is true. So what I'm referring to here is the OR criteria. And of course, this can also be evaluated in Power BI with the calculate function. So let's do that. Let's actually right click on the sales table to create the measure, go to new measure here, and then let's actually do that in here. Just a second, there's the measure. So let's increase the size here a little bit, and there's the measure. And let's say calculate, and now, or we named it sales between 15 and 25. In this case, let's say, sales below 15 or above, let's call this, or above 25. And of course, as I always say, come up with better names than I do here, okay? It's just really for demonstration purposes here. So let's actually go to new line, and then let's say, okay, here I'd like to calculate, use the calculate function again, and now we want to evaluate an expression. So in our case, the expression will be total sales. So I need to spell it correctly, of course. So total sales, here we go. And now I need to give it a filter. And remember from the first videos which you've seen, that as a filter, we could now use either the filter function, which would be the longer way to do it, but you can use it, right? Or we do it as a shortcut using the Boolean expression, so true or false, like we've done in the last video with the sales as well. So we can simply type in sales, in this case from the sales table, the sales amount, and this one would be, in this case, less or equal to 15. And for the OR criteria, as we've seen for the AND, would be double ampersand. For the OR criteria, on the other hand, it would be the double pipe symbol. So you type in a pipe and then a second pipe. This would be OR in Power BI. And then you say sales table, and again referring to the sales column from the sales table, and this should be greater or equal to 25. Okay, 25 like that. And then I close the parenthesis here, and we are good to go. So you see that here we do the same for the OR criteria, like we did for the AND criteria, we just use the double pipe symbol instead. And as I said, this is a Boolean expression, right, which we give it here. So the sales table should be either less or equal to 15, or it should be greater or equal to 25. And the same could be done using the filter function, but it would be a little bit longer, right? Because we would say filter all the sales table and then do the criteria we have here. Instead of that, we can use the shortcut, simply typing it like that in here. Okay, so let's actually evaluate that. So I press enter, and here we go, we got our measure. And if we tick this, just go again in our table here, make this bigger, and then evaluate what we've done here. So sales 15, below 15 or above. So tick this option here, and then we can see we got a different result here. We got 40, 30, 25, and 15. So let's actually have a little quick check here. If we go inside, and we need to first select the correct table, the sales table, and then we remove the filter which we have applied for checking the AND criteria. So let's actually clear the filter, and now let's apply a new filter here and go to number filters, and let's say here there is a between option. Let's tick this between and say is greater or equal. In this case, let's start actually with is less than or equal, and then we specify 15. That's what we had. So 15, not 16, 15. Here we go. And this time we specify instead of AND, we're using OR criteria, and then we say is greater than or equal to, and let's say here 25. So far so good. We can take the filter. The filter is applied, and now we can see what we get here. For instance, for product number 4, we got 15 plus 10, which is 25. And for product 2, which is Red Bull, remember, we only got 30 here because 30 is greater than 25. The 20 value, which we normally also have, is not. That's why it's filtered out. And then we can also see the data for the other ones. But let's stick maybe for the product ID number 4, which is 25, and product ID number 2, which is Red Bull, which is 30. And let's just check product ID number 4, which is 25. Could be Monster, but I'm not sure. So I go to my, in this case, product table here and say, well, it's not Monster, sorry, it's Relentless, therefore. Okay, Relentless should be 25. So let's check that. Go to our view again, and we can see that Relentless here indeed is 25, and Red Bull here, this one, is 30. So the filter gets applied correctly, and we can see the results in here. And just for completion purposes here, of course, we can also do it in a different way using the OR formula. Like we have seen with the AND formula, there's also an OR formula. So let's do that quickly, just to complete it. So let's go with our sales below 15 or above 25. This one here. Let's copy this. Control C to copy it. Let's right click on the sales table here, go to the new measure, and just paste this inside. And as I said, you can also rewrite it if you want. I just want to be a little bit faster here, and I don't want to bore you, of course. That is why I simply copy this formula for now. So let's say here again, version 2, just to be consistent here, version 2, and then say calculate the total sales. And instead of using the double pipe symbol here, I will remove this and put in a comma in here. And then I will wrap all these things here in the OR formula. So OR, and then we have a logical test, same as we've seen with the AND, but this time only one of the conditions needs to be true, okay? So basically returns true if any of the arguments is true, exactly like that. So then let me actually close the OR and as well as close the calculate function. So remember, you need a second parenthesis here. And Power BI is here really helpful because it also highlights here what's the closing parenthesis for the opening one. So let's press enter just to evaluate that, and we can see the measures there for us. So we can tick the option here and let's have a look at the measure. And the table is already too big, so let me actually maybe remove the AND criteria here and this one here as well. But we can see here for the OR criteria, we get exactly the same result. So it doesn't matter whether you use the pipe symbol or you specify it with the OR criteria, you get exactly the same result. So it's your personal preference how you want to do that. If you need an OR criteria to filter based on multiple criteria with the calculate function. So that's it for this video. Hopefully you understood what we did. In case you got questions, as always, feel free to ask them. And otherwise, thanks for watching, and I'll see you in the next video. Until then, best guys. Hey friends, welcome back. Now let's actually explore the criteria, the multiple criteria a little bit more. So far what we did was we used multiple criteria from the same column. Okay, that's important. So for the OR criteria, as well as for the AND, let me actually maybe remove one of the ORs. And let's actually also display the AND one more time, the AND criteria here. What we did, if we take a look at the formula here, we see that we apply sales table should be greater or equal to 15 or less or equal to 25, but based on the same column, right? We said that the sales column from the sales table in both of these cases. What if you would like to actually adjust this a little bit? What if we'd like to say, well, I'd like to see sales from the sales table greater than 15, but also that the product name here should at the same time be, let's say, monster, right? To only evaluate monster sales above 15 or above or greater than 15. So let's try that. Let me actually remove this here and then say we would like to see that the product, and here the product table, from the product table, the product name. So where's it? Product table, product name, down there. This one should be equal to, and then in quotes, I type in monster energy. Okay, like that. What do you think what happens if we do it like that way? So let me show it to you. If I press enter now, what I get here is I get an issue, right? I get an error message here. You can see fix this, and here the expression contains columns from multiple tables. That's true, because I have one from the sales table and one from the product name, so product table. But only one column from a single table can be used in a true-false expression that is used in the table filter expression in calculate. So it gives you a little hint already, but basically the way we do it currently here will not work. That's the main, the main point here. So how can we make this work? Well, what we could do is we could go in here and say, instead of saying it like that, sales table says greater 15, and product table, product name is monster energy, we could say that from the sales table here, the product ID here, this one, is equal to, and for monster it was 1. So I type in a 1 here, and now let's actually try this as an evaluation. I press enter, like that, and let's just see, and here we go, we got a correct result. So obviously this works, as you can see here, we got here sales for monster, but only the sales, in this case, which are greater than 15, right? That was the condition here. So if I go back to my formula, which we have here, evaluated the last one, sales between 15 and 25. So this one here, we see that this works properly without any errors. Why is that? Remember what the error message said. When we used, or were referring to the products table, we basically used multiple tables, so the sales table as well as the product table, in this Boolean expression here with a double ampersand. And this will never work. We need, if you want to apply the double ampersand here, the multiple criteria of the AND condition, you need to refer to the same table. You see, it don't have to be the same columns, because here we use the product ID, and here you use the sales column, but at least it needs to be the same table. That's the premise, okay? So let me actually maybe go back for now and paste this inside. This was the original measure. Now, what if you want to actually use something like an expression like sales table is greater than 15 and the product name should be Monster Energy, because you don't want to keep all the product IDs in mind, right? You can't remember all of them. Maybe you have a bigger table and you don't want to do it like that. Instead, you want to say, I want to see the sales greater than 15 and the product name should be equal to Monster Energy, right? So can you do that? And yes, you can do that. So how? Well, let's actually create the measure. Let's say sales greater than 15 and the product name should be Monster Energy. So I can right click on my sales table here. I say I'd like to create a new measure. So just a second, here we go. There's our measure. And then we say, we would like to say, these are the sales, Monster Energy, above 15, okay, like that. And now it's equal to, and now I go to new line and say I want to calculate here. Now the expression will be the total sales, so total sales. And then as a filter here, we say for the first one that the sales here from the sales table, the sales column should be greater or equal to 15. So far so good. And then we want to make sure that next to this condition here, we would like to have another condition. That is why this time I don't use the double ampersand symbol, I use a comma. And the comma allows me to now apply a second filter criteria here. So basically a complete new table, if you want to call it this way, because that's what it basically is. And my second table, or in this case Boolean expression, is that from the products table here, the products table, the product name, this one here, should be equal to, in our example, Monster Energy, right? Like that. I can close parenthesis now, and I'm good to go. And if I press enter now for this measure, just to evaluate it, we see that here we don't get any issues. No error message, it seems to work. And if we visualize that, if I go in here, let's see what we get. If I take this option, we basically get 25, but now everywhere. So we got the correct result, which is 25, for all the sales for Monster Energy, which are greater than 15. That is true. However, we can see it everywhere. Why is that? Remember, in Calculate, we have an external and an internal filter context. The external filter context is coming from the visual. So Monster Energy, Red Bull, Relentless Rockstar. So each of the lines in here. And the internal filter context, if I go back to my Monster Energy sales, this one here, is specified within the calculate function. Now, because we are referring to the product table near the product name, which is Monster Energy, and we use the exact same column in our table, this one here, the external filter context, so this column, gets overwritten by the internal filter context, which is coming from our filter here, so this one. And that is why for the calculate, instead of seeing the different energy drinks in our table, it sees basically the name Monster Energy in each row. And that is why it simply returns the 25, which is the evaluated expression for product sales above 15, everywhere in each row. That is the reason for that. If you want to avoid this behavior, you have two options. You can either specify here that instead of the product name, you want to refer to the product ID, okay? Here, product ID, like that. But then, of course, you need to specify not Monster Energy drink here. You need to specify the one, because the one was Monster Energy. And if you press enter, if you do it like that, press enter, you will see that now for the evaluation here, you only have, let me untick this here, the 25 really for the Monster Energy drink column. And again, the other ones are empty. And the reason for this is because now, in the formula itself, if I go back to Monster Energy here, we have a second expression, the second table, which is returned. But this table is referring to a column, which is in this case product ID, which is not available here in the visual we have here. And because we have two different columns, so the internal filter context is not completely overriding the external filter context, because this external filter context, like the product name, is not within the calculate function specified, and that is why you don't see anything here. It doesn't get overwritten. Okay? So you can get this behavior, but then you need to make sure that what you put inside the calculate function, as we've done here, that this second expression is not, or the second column here, this is not somewhere visualized in the table or in the bar chart or whatever kind of visualization you have. Okay? Then you get the behavior like that you only see it for one specific column. If you refer to the same column you have already applied in the visual, then it gets overwritten, the internal filter context prevails, and you see the same value everywhere. Okay? So that's how that works. And that's it for this video. So thanks for watching, and can't wait to see you in the next video. Until then, best guys. Hello friends, welcome back. Now let's figure out how we can use or leverage the calculate function to classify our sales in high sales, medium sales, and low sales. To do that, we also need to apply the count_rows function. So my idea here is, if we go to our sales table, this one here, and first select it, of course, the sales table, this one, and maybe remove the filter for now. So clear our filters. We can see that in total we got 2, 4, 6, 8, 9 entries. Okay, so basically we got 9 sales of our products. So let's actually figuring out how many, well, amount, in this case rows, do apply or belong to which product. We can easily do this by a simple formula, which is the count_rows function. So let me show this to you. I right click on my sales table. I say I'd like to create a new measure in here. And then I go in here and say this will be, in this case, simply the count of sales. Count sales is equal to, and I only want to use the count_rows function here. And it tells you what it does. It counts the number of rows in a table. That's all what it does. So if we put it in here and referring to a table, in this case our sales table here. So we are done. We're good to go. I can press enter. And then this will simply count up all the sales we have. So we can easily check this. If I go to a card visual, tick this option, and put in the count of sales, we see that we got count of sales 9, which we would expect because we got 9 entries in the sales table, right? So far so good. Now let me just make a little bit more space here. Let me make this smaller here so we can have a little bit more space in here. Okay, and let's also make this smaller in here. Just a second. Okay. So by default in a card visual, we don't have any context, no filter. So that is why we can see the total amount, which is 9. If we would use the measure we have created, the count of sales, in the table, then we would have a filter context in here, which are these product names. So we can tick this option here, go to count sales, and then we see 3, 2, 2, 2. And basically in total we see 9 entries because we got 9 rows. Okay? And that is true. So we see that for Monster Energy, we got 3 entries in the sales table. And just a quick check, Monster Energy is the ID number 1. So if I go to data and take a look, there's a 1 here, there's a 1 here, and there's a 1 here. So we got 3 entries. And for all the other products, there are 2. So that's totally fine. And that works. We can see the data, the correct amount of rows of sales we have created here. So far so good. But what if we would like to create an additional table for the classification? As I said at the beginning, what are the sales which we would consider as, in this case, high sales, the medium sales, and let's say the low sales. Those 3 criteria, which we can simply specify or define if we set a table and set certain kinds of conditions. So let's say all sales between 0 and 10 are actually low sales. Sales between 10 and 20 are medium sales, and all sales with amounts greater than 20 would be considered as high sales, just as an example. So in order to do this, we at first need to create a table, because currently we don't have low, medium, and high. To do that, I will go to Insert here, and to Home here, and under Home, there's an option to enter data. Now, in the past, we have used under the modeling section the option to create a new table from here. The difference is that this new table here is referring to a DAX expression, which we need to create in order to create the table, like we have done, for instance, with the values function. The Home, on the other hand, so enter data here, is referring to manually enter data. And that's what I want to do here. So I can press enter data here, this option. And then there's our table. We can specify here the column name. So this could be, for instance, the classification here, and then I simply type in here, this will be low, then go in here and say medium, and then the last one would be high. And then of course we need to say set some thresholds, like let's say top and bottom. So let's start here, double click here, let's say this is bottom, and then here we go into top, okay, top. And let's say for the bottom, for low, we start with 0 sales, and the highest is 10. Then for medium, we can start with 10 here, and then we go up to 20. And finally for the high, we got with 20. And the top, you could say a really high number. In my case, I know I don't have sales in this dataset above 30, so I can set the top to 30. But if you don't know in advance, you could put in a really high number in here. Okay, so we have specified the classification table. And now, of course, we can simply name this table, right? Let's say for this name, we say sales classification, okay, like that. And then we can click on load, and then we are good to go. So if I click on load, we just need to wait a few seconds until this new table has been evaluated, and now it's been created, and the model checks whether there are dependencies it can create, and then the new table appears in here. There it is. Sales classification table. And of course, if I go to the model view, if I take this option here, and sometimes it's a little bit hidden, so you need to either zoom out using the control and the mouse wheel, or you simply close the property window just to see that the table is appearing here. You see again that the sales classification table so far has no relationship to our original model, which is quite simple here, only those two tables, but it's important to understand that there is no relationship directly in here, okay, between those two. So that's fine. So let's go back to the report view here, and now let's actually visualize our sales classification table. So I can tick this option, and now if I go to the classification, tick this option here, we see our classification in here. And of course, I also want to make this bigger so you can see that better on your screens. So let me go to the value section here and choose just a bigger text size. Could be 15. So hopefully that's big enough for you. So you should see now high, low, and medium. And of course, you can sort this the way you want it. Also, you can add an additional sort column if you want, if you need this, and sort by this column, right? So just an example here, if I go to my specific table, let's go with the, where is it? The sales classification table I've created, and I want to keep this kind of sorting here. What I could do here is I could add an additional index table. I'll right click on table, and let's actually say I'd like to edit the query. And then I could say, okay, here's my query, and let's actually now add an index column here. So let's say add column, and say we'd like to add an index column, okay? So add index column from 0, from 1, doesn't matter. In this case, I tick from 0, so I got my index. What I want to name this is actually only sorting, okay? Sorting, here we go, and then I go to home and click close and apply. And then also I get my sorting column created in here. Just a second, and there it is, okay? So that's sometimes helpful because now I can actually select here one of my columns, like the classification, and then I have an option to sort by. And here I can choose a different column. Like for instance, my sorting column, I can tick this option. And as soon as I do this, if I go back to my report view here, now you see that low, medium, and high is correctly sorted. So sometimes if you don't get the sorting you want by using the normal sorting options, like clicking here, for instance, or on the visual itself, clicking here and choose sort. If this doesn't fit for you, then what you can always do is add an additional sorting column to your table, as we have done here with this one, and then you can sort a specific column by another column, okay? So that's the trick here, and we got our classification. But now let's go back to our original goal. We want to actually classify our sales, right? So if I tick now the count of sales which we have created, remember, if I take this option, what do you think what will happen in our table in here? So let's actually explore that. Let's tick this option, and you see we got 9 everywhere. So basically the 9, yes, 9 is correct. We got in total 9 sales, but of course we don't got 9 sales classified as low sales. 9 is medium and 9 is high. That's not true. So obviously this is not working. And why is that? Well, the answer to this is quite simple. Because remember, if we go back to the model view, we don't have any relation to our model. And as long as we don't have any relation specified, then of course, if we do not use any DAX measure, anything else, to create this relation, then we would see always the same value repeating, which is the total amount. But that's of course not what we want. We want to do the classification correctly, so we need to adjust this a little bit. So let me just right click on my sales table to create my new measure. I take this option here, and here we go. There's our measure, and let's say this is the correct sales classification. Okay, so we got this one, and say is equal to, and I go to a new line, and I say I want to use the calculate function. So we're good to go. Calculate, and our measure will be the count of sales, which we have already created. This one here, count of sales. But now we need to evaluate it in a new filter context. So removing the default one we have and create a new one. And the new one will be created using the filter function. So we've used this already. Filter returns a table with a specific filter expression applied. So basically a filter table. So the table itself will be the sales table, not the sales classification, but the sales table itself, sales DBL. And then we want to make sure that from the sales table, the sales column, this specific column, should be greater, the space greater than the minimum of the counting table which we created. So our sales classification table, and there we had the bottom, right? So we're referring to the bottom of that. And then at the same time, that's why we use something we already know or familiar with, we double ampersand, because both criteria must be checked, must be valid, and must be true. So at the same time, the sales from the sales table, the same one here, is less or equal to the maximum. So maximum as an aggregation. And for the column, we're referring to the sales classification. And here we say the top, this one here, okay? And we can close the max. And then we need to also close the filter. And finally, we need to close the calculate function. And that's our expression here, right? So basically what we tell it here is we want to calculate the count of sales, but in a modified context. That's why we use the filter function here. And this filter function will evaluate the sales table. And this sales table will now be filtered down based on this criteria. So we want to make sure that the sales table, the sales number, is greater than the minimum of the classification table from the bottom column. And at the same time, it is less than the or equal to the maximum of the top. And this sales classification bottom and sales classification top, those two are available actually in our table here, because each of the classification modes, the low, medium, and high, have a bottom and a low attached to them. Okay, so that's why those values are available in this specific filter here, so in this visual. So let's actually press enter for now. And so we got this. And just by the way, if you want to filter this properly, of course, format this properly, that's what I wanted to say, then of course, feel free to use any kind of tool like DAX formatter, for instance, and so on. You can do that easily. So, okay, let's go back to the visual. Let's see whether this measure we have created here is really evaluating now properly. So let me just tick this box, tick it now, and we see we got 4 and 2, which is in total 9, so that's correct. And we have our classification. And this time, as I said, we see the correct numbers in here. So we got 3 sales, which are, in this case, below the threshold, or let's say greater than the minimum, but less than the maximum threshold. So we got some medium, which are those, and high, which are those. So let's go back to the table. In this case, we set for the low, we set 0 to 10. So if we go to the sales table in here, we can see that we got 10 value in here, a 5 value in here, and a 10 value in here. And because we say less or equal to 10, all these should be classified as low. This means we have 3 entries in our total sales table here. And if you go back in here, we can see a 3 in here. And now we know this is evaluating correctly. The same is true for the other ones. If you want to check that, you can do that. Okay, so that's our formula. And that's how we can leverage the calculate function, in this case, to correctly classify our customers. So that's it for this video. Hopefully you enjoyed it. As always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hello and welcome back. In this video, I'd like to actually do some kind of cleaning for this specific Power BI file before we create a new Power BI file and actually importing the data which we need for the next couple of videos. So if you already know me, then you know that I personally prefer to have my measures structured in a measure table instead of having them actually appearing all around here in various tables. So in order to do that, there's the so-called measures tables trick that can be easily done by going to home and then click on enter data here. I take this option and then I can simply name this is my measures table. So I'll call this measures TBL like that. And then I simply need one dummy column. I leave it for now, the column 1. I click on load just to create my measures table in the model. Just a second. And there the table gets loaded. And now it's available in here, the measures table. And then what I like to do is I like to move my measures into this measures table. And this can be done quite easily. Instead of doing it manually, you know that each of the measures, if you tick this option, has under measure tools, the option to specify the home table. So you can do this manually for each of the measures and specify in which table you want to move it. As an example, the measures table, for instance. Then you would see that now it's placed in the measures table. But this, of course, is tedious if you need to do it for each of the measures, in case you have not created this measures table from the beginning. So what you can do to speed things up is simply go to the model view. You can tick this option here, and then you can simply choose these measures, like these ones here. You can hold your shift key to select several of them, or your control key to select them individually. You can also do that. So select all the measures I have in here, like these ones, and this one, this one, and this one. So these are all the measures we have created so far. And then we can simply choose what kind of table you want. You could go to the properties to also display them in a folder if you want. But what I want is actually I choose all of them and I drag and drop them on top of the measures table. Then it gets a dotted line around. And if I drop them there, you see that now they're all placed in this measures table. So quite easy and very quickly. So we avoid to doing this manually. And then if I go back to my report view here, yes, apply the changes for now. So far, let me just take this option, discard it here for now. And then what I like to do is I like to click on the 3 dots for the column. I like to remove, in this case, I don't need it anymore. Delete from model, that was just a dummy column. I click on delete here. And then, so far so good, just a second, here we go. And now I have my measures table with the calculator icon here, right? So in former Power BI versions, I had to shrink the window from the fields and reopen it again. Then the calculator icon for the measures appear. Now it's appearing automatically in here, okay? And now I have a table which only contains my measures in here. And I think this is a little bit more structured. But that's up to you, whether you want to do it or not. Okay, so we got this. And that's actually it for this file. So I press Ctrl S to save my model here. And then I will open a new Power BI file. I already did that for a new model, which we need in the next couple of videos. And here I'd like to import my data. So I go to get data here, or click on Excel. It's also an option, or click on Excel here. It's really up to you how you want to do it. So get data here, I click on Excel, and then I'm choosing my Power BI training file number 2. Once more, I click on open just to reopen the report. And then I need to simply build the data model just quickly. So just a second, here it is. I can import the tables or the sheets directly. So if you know me, then I personally always prefer the tables. So I make sure that I import only the relevant data. So I tick these options here, and then I go to transform in here, and the query editor opens. Okay, so far so good. And then what I like to do here is I like to simply check my tables here, whether they are set up correctly, whether the data type is correctly set by Power BI automatically. It looks that way, at least for most of the columns. There's one little issue here with the ship date, so I can easily modify this. I can go in here and say I'd like to change this to a date. So I tick this option here, and here, no, I'd like to add a new step, just to make sure, and let's see, and we get a few errors here. So what's the problem? In this case, with dates, as well as sometimes with numbers, remember, it has sometimes issues because we live in different countries, and we sometimes have different ways how dates are actually specified. So here, month, day, or day, month, year, and so on. So that is why if you convert something in Power BI and you experience errors, then my go-to trick is always to tick the option here and say I'd like to go with using local. You can tick this option here, and then you can specify a local or try out a local date format. In my case, what I know actually is that in this case, Germany should work. So let's try that out. Let's go to here a date, and I want to use a German date. Let's figure that out. I click OK, and I still got the error. So if this is also the case for you, then my best trick or the best idea I can give you is, if you have a number in here, please first make sure to click here and convert it into text. You can add this new step, and this would always work. So this should never return an error actually. And then let's try that one more time. Click on the ABC, and this time using local, the go-to trick, and just wait until that opens. And now let's try that one more time from the text to the date. And again, I'm trying with the German date format here. I click OK, and now that works. Okay, now we have a proper date here for the ship date as well. So as I said, sometimes a little bit of trial and error, but what always works, at least so far for me, and that's why I can give you this tip, is convert it first into text and then convert it into a proper format using this option using local. Okay, so that's it for basically the orders table we have here. So that's why I would like to rename it here. Let's call this orders, and then I go press enter just to rename my tables here. The second one is this one, which are my employees. So let's call these employees. Okay, here we go. We got the employees table, and then finally here, table number 3 are my suppliers. So I also name these properly and say suppliers. So for me, I know I don't need to change anything here. This should actually work fine for me, but otherwise I always encourage you to try out and check out the data types here, and also whether you have missing data somewhere. As an example here, if I go to my orders table, and if I scroll to the right here, let's check that, and there should appear a column, which is my customer zip code, and you can see here a black part of this bar. And this always refers to the fact that there are missing values in the customer zip code. You can also check that if you go here and say, I'd like to see the nulls. So null is referring to missing. You click OK. And then you see there are obviously customers, at least one, which is in this case Patricia McKenna, and there is no zip code available for her. So this is something, in our case, it doesn't matter too much, but if this would be a real dataset, a real case dataset, then I would encourage you to reach out to the department who provides the data and then figuring out what is actually the zip code of, in this case, Patricia McKenna, if you use this column at all. I mean, if you don't use the column, you could also remove it from the data model. But if you, in general, if you have missing data, then always try to figure out why you have missing data and go to the responsible person to get the data you need, okay, to fix that. And here Power BI is really helpful, at least from my point of view, because of these bars. And if you hover over them, you get exactly some information what's actually the issue. So is there missing data? Then you have a black bar. And if you have errors, then you would also have a red bar in here. Okay, like we have seen when we converted the date to ship date, right? Okay, so we got our 3 tables. So they are good to go. They are fine. And now if I click on close and apply, just to load this, we just need to wait until the data gets loaded into the model and the relationships are detected. So just a second, and we got our data. So far so good. And the tables are appearing on the side. And the final part is always going to the model view, just to make sure that actually this works fine. In my case, I need to upgrade it now to see the new view. Probably you in the future will already see the new model like that, the structure. And I got my orders table here at the bottom, and I got my 2 other tables, employees and suppliers. And finally, one thing is missing here currently, which is the dates table. Always best practice, import your own dates table, and you can get this from the source section. This dates table here, I can simply go in here, I can copy all of this. You can write it yourself if you want, but you can also, of course, use this in the future for all your Power BI projects. Simply copy it and then go under Home, in this case, Get Data, and there is an option to use a blank query to paste the M code. Then the Power Query editor opens, and if you go to the advanced editor here and remove everything which is inside and simply paste here the M code. So quite long, but as I said, you don't need to remember it, you can just use it. And you click on done, and then the function gets created, and here you can specify a start date, an end date, and a financial year start month, and also on holidays, table or calendar, calendar if you want to apply some, you can also do it, upload it here. So let me just go with start and say the 1st of January 2019, and the end date will be the 31st of December in 2021 for me, and the financial year start month is January. That's fine. And then I invoke the function just to create my dates table. Invoke it, and here is my dates table, and then let me actually rename it here to dates. Press enter, and I have my final table here also created, and I go back to close and apply just to load my query inside a Power BI desktop in the model, and then I can also connect this table to my current model. Of course, it's always hidden on the right side, so I need to go out there and also actually paste it here as well, and also create a connection between, in this case, my dates table and my orders table. Drag and drop it on top, and then we also create the collection from the one side to the many sides, so 1 to star, between the two fields, which are highlighted if you hover over the relationship. And so far so good, that's it. So we have set up the model which we need. In the next couple of videos, we explore the calculate function using this model. So I can't wait to see you there. Wish you all the best. All right, welcome back. Now in the last video, we set up our data model as we've seen here. And now let's actually go inside the report view and explore a little bit the calculate function in relation with other important functions like the all function as well as the all selected function, and what's the main difference between those two. At first, of course, I need to have a few measures, and the easiest and simplest one will be the total sales again. So I can refer to my orders table here. I select I want to create a new measure, and this measure will be simply the total sales. So let's go in here and we will calculate this kind of similar to what we've done before. So our total sales is equal to, and now I say simply this is the sum of my sales from the orders table, the sales column. Okay, quite easy, nothing special in here. I can press enter, and we have created our first measure. So far so good, and quite easy. Now let's actually visualize that. Let's go with the category in our case. I can tick the category just to show a table by default, and then I would like to see the sales figures. So I can tick my total sales, or I can drag this directly in here in the values. Both will work. If I drop it here, I can see the sales amount for each of my categories. And just to make this bigger on your screen, let me just go to the total section here, or sorry, the value section here, and then I can make the text size, let's say, go with 15. Let's just see that should work actually for hopefully all of us. Okay, so far so good. Now we already know that in order to get the total sales, so basically ignoring the filter context, which is in this case the external filter context, which in our case is the category, we have the option to leverage the all function to do that. So we could say that for our, let's call them overall sales or total sales without any kind of filter. So let me right click on orders table, new measure, and I will go with the name overall sales, but of course you can name this whatever you want. So for the measure itself, let me tick this option, and let's go here with overall sales is equal to, and we already know that we can leverage the calculate function. The calculate function needs an expression, which is in this case total sales. Now we've set up prior to that, and then we can give it a filter expression. And we know, we have seen this in the last model, then when we use the all function, the all function itself needs either a column or a complete table. And if we give it a table, then simply all the rows in this table get basically returned. So that means that all other filters get removed. Okay, here ignoring any filters that might have been applied. And this ignoring filters is referring again to the external filters in our case, which are coming from here, right? Directly from the visual we have. In this case, a table. So we can simply refer to the orders. And if we refer to the orders table, that means we keep the complete orders table and remove any kind of filters which are coming from this table. In this case, it's only the category, but also any other kind of columns, which we could use here in the visual for filtering, would also be ignored. Because we simply say we want to have the complete orders table and evaluate the total sales. So then we close parenthesis to actually create or close the calculate function. I can press enter, and we can easily evaluate that. We can go in here and tick this option here, and then we would see here the total sales, which is 1.35 million, which is the total sales in the whole dataset. So we're ignoring the external filter context simply with the all function. And what I meant when I said was referring to the complete orders table here, that means that all filters from the orders table, so also if I tick as an instance, let's say I'd like to add here also the ship mode as an example, I can drag my ship mode inside the values here as well. but because it's coming from the same table, it doesn't matter here, actually, because the overall sales will always be here, the 1.35 million. So the category is ignored as well as the ship mode. Everything is ignored which comes from this table. Okay, that's the idea behind that. So let me remove this one more time. I just wanted to show this to you. Okay, so what if we would like to create the percentage? We also can easily do this. We can simply divide the two measures. And by now we know that best practice, we can use the divide function for that. So I can right click on my orders table and say new measure. So there's the measure. And then I could say here for my measure, this will be the percent of total. Okay, so and then it's equal to, and now I simply say this is divide. The numerator will be our total sales, and the denominator will be, in this case, the total sales, what we had with the all function, which is referring to the overall sales, which I named it. Okay, and you can specify an alternate result if you want. For me, I just skip that for now. Then I can press enter and evaluate this formula. And if I go to my table again and I tick the option here, percent of total, then I would see this as a percentage number. Of course, it would make sense to format this correctly. So I select it currently and I tick the percentage symbol here just to get a percentage number in here. Okay, so far so good. So that works fine. And I can see the amount of sales for cheese based on the total sales. So that's fine, and you can see 100%. But what if I like to actually now use an additional filter, like another external filter, but which comes from another visual? So all the filters, not only this one here, which is currently in the same visual, but also filters from another visual, are external filters. What I mean by that is if I, for instance, go with my region, I can tick the region option here, and I like to make this a slicer. And I also like to increase the size a little bit. So go with items here and say also here for the text size, I go with 15. Okay, 15, here we go. So that's fine. I can make this smaller here. That's my region slicer. And let me just drag this maybe down there. Now, let's actually also create a card here. Select the card and here also add the total sales. Just an example, we have another visual, which simply shows the total sales amount, which is 1.35 million, which is the same value as here, right? The total sales. So far, so good. Now, let's actually filter the data. Let's say I'd like to see the sales for America. I can take the region America and watch what happens. I see 526,000 in total for America. Okay. I can see this also here. The total sales is correctly filtered. That's what we would expect, right? But the overall sales is not filtered at all. So you see that because the region itself is coming from the same table, and because we use the all function to remove any kind of filtering from this table, so any external filter context, that is why even though we filter here with another visual, we still see the 1.35 million everywhere. So this hasn't changed, okay? And that means that if we want to calculate the percent of total, you see that now it's the filtered total sales for the region America based on the overall sales without any filter applied. And that is why you don't see the 100% there anymore, right? So what can we do about that? I mean, if that's the behavior you want, then you're good to go. But if you don't want this behavior, instead you would like to see, actually, if you apply another filter from another visual, like the region here, for instance, you would like to see a filter of the overall sales based on the region, so that the percentage, again, would add up to 100%, because not only the total sales is filtered based on the region America, but also the overall sales is filtered based on America. Ignoring still the categories, right? That's what we want to have. How can we do this? Well, we just need to slightly modify our overall sales formula, which we have here. Because of, instead of using all, there's also a function which is called all selected. And that's exactly what we need in order to solve our problem. So we can copy this formula here, Control-C to copy it. Then I go to the orders table, I right click here and say I'd like to create a new measure. And there's our measure. And then I paste it inside. And I simply name this overall sales, let's say corrected. Okay, corrected. And as I said, feel free to come up with whatever name you want, a better name hopefully. and I'm sure of that. So this is the overall sales corrected. Now I want to calculate my total sales, that's fine. But this time, as I said, I don't want to use all function because the all function ignores all external filter contexts, which gives us exactly the behavior we have here, right? So also ignoring here this region filter. But we want to apply the region filter. We just want to ignore the, in this case, what's coming from the table directly. So I want to ignore here the categories here, but still I want to see the data here for the total for the region America or Europe, depending on what I choose. So that is why I can say, instead of all, go in here, I'm using all selected. Here we go. And you can tick this option, and here it tells you what it does. It returns all the rows in a table or all the values in a column, depending on whether you put in a table here, like we do here, or you put in a column, like orders and then a specific column name, could also be the case. But it actually, here, ignoring any filters that might have been applied inside the query. So this is referring actually, in this case, to what we see in the visual, so in this case our categories, but keeping filters that come from outside. And you can think of it this way. So what's ignoring basically, everything inside the query is ignored. So basically this is coming from, in my case here, the different kinds of categories I have in the visual. But what's coming from outside, which actually is, in our case, the region filter which is applied here, this will be kept. Okay, this filter will still be applied. And let's actually take a look at that. Let's first go back to our new modified formula, correct it, and press enter. Just to create it. Okay, now there it is. Let me then remove the filter for now. Let's go back to our table, select it, and also add the overall sales corrected. Take this option here. Now we can see we got exactly the same value here as we have for the overall sales. Exactly, that's exactly the same. So far so good. But now if we create an external filter context, right? The internal filter context, like here, the category is still ignored because we can see the same value here, the total sales. But now let's apply the other filter here, coming externally from another visual. Let's take the region America. I take this option here. And we see for the overall sales with the all function, we still get the total value. So this filter is ignored as well as this filter is ignored. But for the overall sales corrected, the category filter here, this is still ignored because it's within the query, it's inside the visual. But the external filter from another visual, which is coming from outside, as we've read in what the all selected does, is actually taken into account. So the 526 is exactly the total sales, as you can see here as well, for the region America. And this is kept here. And that's the difference between the all function, which is ignoring everything, and the all selected, which is ignoring, in our case, what's within the filter here in the visual, but still keeping filters which are applied from outside. And this allows us now, of course, also then create calculate the percentage of total as corrected values, right? So we can simply also say here it's now here. If I right click on my orders table, go to new measure and say percent of overall, let's call this here percent. Now we named it, the other one we named percent of total. Let's call it percent of total corrected. And again, I'm referring to the divide function, so divide. And for the divide, we need a numerator, which is the total sales, a denominator, which in our case is the overall sales corrected in this case, this one. And then we can specify an alternate result. In my case, I just skip that. I close the parenthesis, I press enter, and here we go. And let's actually tick the percentage immediately, just to make sure that we got two decimal numbers and the percentage symbol. And now if we take a table again, go with our percentage of total corrected, click this option, then we can see here we got different values from this one. And again, in total, they add up to 100%. And the same is true, of course, if you use Europe here. If I click on Europe, then this would also work in here, right? And also if you apply additional filters from outside, from other visuals, they would also get taken into account. And this will always add up to 100%. The all, on the other hand, this one will ignoring all the filters coming from the orders table. If it's internally, so from the visual itself, in this case, so this external filter context, or it's coming from an external filter context, which is applied outside. It also gets ignored, as you can see here. Okay? So that's it for this video about all and all selected and how you can use them in combination with the calculate function. So thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hey friends, welcome back. Now let's talk about the keep filters function, because this function is also often used in combination with calculate, and let's actually explore what it does and how it can be used. So at first I'd like to create a new sheet, because here I already have used a lot of space. So let's actually rename this here, this page to, let's say this is all versus all selected. And then I click on the plus symbol here. What I want to do is I simply copy this table here, Control C to copy it, and I go to the new page, Control V to paste it, just to make sure that I simply copy the format. That's what I actually wanted. I can remove all the values, in this case what I don't need, all the measures, because everything I need right now is the total sales itself as well as the category. So start from here. So now let's actually explore at first the sales for a specific category. So using the all function, we already know how that works. We have explored that in the last couple of videos, but let's actually do this here as well, just to see also what the comparison is to keep filters. So I could say I'd like to see my total sales, but only for a specific category. So we can say, we know we can do this with cheese as an example. So I could right click on my orders table. I can say I'd like to create a new measure. And then I say I want to calculate my total sales based on a specific category. So I could say this will be the sales for cheese is equal to, so let's say calculate. And as an expression, we say we would like to calculate the total sales, and then we need to give it a filter context. And we know that we could use the filter function for that. So filter needs a table, and this table it gets filtered by the filter expression. So we can say filter, and then we need to give it the all function. So all. This is important. So oftentimes, if you apply the filter function, people forget to use the all function. Okay. So if you want to remove any kind of filter, use the all function here for the first argument for the table. So then we are referring to the table. In our case, it's orders, and we can close this. And then we need to give it a filtered expression. So please return the complete orders table, but this orders table needs to be filtered by an expression we set. And we say that the category here from the orders table should be equal to, in this case, cheese. Okay, cheese, like that. And can close this and also close the calculate function. And let me also put this in a new line here, like that. Okay, we got our formula and evaluate it. So if we press enter, we will see what we get, and most of you probably already know that. So if we now take this option and take this option here just to visualize it, we will get the same value across all the different kinds of categories, because we simply use the all function and the calculate function to override the external filter context. Always remember, from the visual you have external filter context, which in this case is each category for each row, but within the calculate function, in this case sales for cheese, we have internal filter context for the category, and this internal filter context gets compared to the external and is simply overriding the external filter context. So far so good. And we know, just by the way, that this expression here is the same as if we want to do it short. We could simply say that the category is equal to cheese, so equals cheese, and this would be exactly the same value. So just to show it to you, if I press enter here, you would see that you get exactly the same result. So nothing changes in here, right? But for me now, because I would like to show this in comparison with the keep filters, I simply want to refer back to the original complete formula, this one. So that's one way to do it, of course, with the all function. And we also know if we modify this function slightly, so instead of using all, we use values, we get a slightly different result. So let me just do this, but I will copy it. So sure, just to make sure that we do this quite quickly, because we already know how that works. We right click on a new measure here, and we paste this inside. Here one more time. We simply say sales for cheese, let's say 2 as a second example. But this time, the only slightly modification we make is instead of using all, we use the values function. So values, and the values, as we already know, is returning a unique list for a table. So a single column of a table with unique values here. So basically removing any count of duplicates for the column. So it gives us a unique list of, in this case, the categories we have. but the values function is not behaving like the all function. It's not simply ignoring what we have here. It's simply taking this into account as well. And that is why if we press enter here and go to our function here, our table, and actually evaluate this function, so tick the option, we would see the result for cheese. That's what we expect. But for all the other categories, we simply don't return anything, because the context here would actually be the external filter context, condiments, as well as at the same time the internal filter context. And both these filter contexts together, of course, the intersection doesn't return anything. That's why it's empty. Okay? So the final thing now, which we'd like to discuss, and actually the main point of this video, is the keep filters function. So the keep filters function, how does that work? Let's actually go to our sales for cheese one more time. And finally, I will copy this one more time because it's actually quite the same expression. So now let me actually right click on the orders table, create new measure here, and let's paste this inside here and say sales for cheese. So with the keep filters, so let's say 3. And instead of using filter values orders in order categories cheese, we will remove the whole second part. And the only thing we need to do here is we say we want to keep the filters. So let's say keep filters. And here you can read through it. It changes the calculate and calculate table functions, so both of them. Filtering, and so here filtering semantics. So what you need to do is you need to now give it an expression. And this expression could be a Boolean expression again, so that the orders table, and from the orders table the category itself, is equal to, in our example, cheese. Okay, simply type in cheese here, or whatever kind of category you want to test it with. Works exactly the same. And then we need to close the calculate function, and we are good to go. So that means the keep filter function, it does exactly what you would expect it to do based on its name. It keeps the filters. That means it keeps external filters, like in this case each of the rows in the table. These filters will still get applied, but in addition to this filter, also the filter you specify here gets applied. So actually both of them. And the behavior will be exactly the same as the values function. So I'm going to show it to you. If you press enter and now tick the table and also evaluate what the keep filter function will do. So if you tick this option, you'll see you got exactly the same behavior as the values function. Because you can think of it this way, as I said before, keep filters means please use this new evaluation context from the calculate function, so this one, but keep the filters which are currently applied from external. In this case, each of the categories. And then again, you have the same behavior as the values function. You have an intersection between the internal filter context, this one, and the external filter context coming from the visual you have. And then of course, if you do it this way, then for cheese and cheese, this is the only combination intersection which makes sense and actually returns a value. And that is why you only see here a value for cheese, like you have with the keep filters, with the values function. So keep filters and values function, or the calculate with values function, behave exactly the same. So you can use them interchangeably, whatever you prefer. Okay? So that's it for this video. As always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hello and welcome back to the next chapter of the calculate function. And this time we'd like to talk about modifiers and how calculate allows us to modify relationships in Power BI. At first, let me actually double click on this page and name this maybe, let's say, keep filters. So keep filters. And then we simply click on the plus symbol to create a new page. And here I'd like to display at first my, let's say, the dates table. And from my dates table, I like to see the date. By default, I have the hierarchy here, but in this case, I remove the day as well as the quarter here, just to keep the year and the month combination for now. Okay. So, and as I said before, you can disable the out-of-date time feature if you want in Power BI using under File the setting options, right? Go to File Settings, so File as an example, and then go to, in this case, Settings, Options and Settings here, go to Options, and here you can specify whether you want to actually keep the out-of-date time and the hierarchy by default or not, depending on the model size, right? If you have a big model, I would disable that. If you have a small model and also only practice with Power BI, then you can leave it enabled if you want to keep the hierarchy. Okay, so far so good. Now let me actually create here a bigger size go in here and say for the values, let's say here I'd like to increase the text size and put in a 15 in here, okay? So, all right, so we got the year and the month. And if we want to evaluate here now the measure, let's say in our case, they'll go with the total sales scan. So I tick the total sales option here. There we go. We can see, of course, I need to select the visual first. Make sure you select the table first, and then you tick on the total sales. And now we can see the values here for each year-month combination. You can see the sales value. So far, so good. Now, calculate as a modifier allows us to modify a relationship. So as an example, in our model here, remember in the data view here, if I go to my table here, my orders table, let me tick this option. Next to the orders date, which we currently use in the relation, we also have a ship date, right? This one. So because the order date and the ship date are actually different dates, right? Because we do not always ship the freight on the same day. That's why there's a difference in here. And if there's a difference, that means that if we use the ship date instead of the order date, then also the values for the total sales by month would change, right? Because it could be that we sell the product in July, but you only ship the product in August. Could be the case. So that's why the numbers would be different. So what if you like to see the total sales numbers for the order date, but also you would like to know, okay, this was the amount of ordered sales, but what of those sales were actually shipped? So if you want to do this as well, you need to go to the model view here and also create a relationship here first between the date here and the ship date. So currently, if you hover the relationship, you can see date and order date are connected. But in our case, if I scroll down, what I want is I want to have a relationship between the ship date here and the date here. I can do that by dragging the date here and also drop it on the ship date, right? Like that. If I do that, you see that another relationship gets established here. I can hover over it, I can see, there it is. However, there's a difference, and the difference is the dotted line. Hopefully you can see that. The line is dotted here, but here the line is actually a normal line. So what's the difference? Well, the dotted line is referring to the fact that this relation is currently inactive. Because Power BI, by default, only allows one relationship to be active between tables at the same time. So we can make this relationship active if we want. However, if we do that, then the relationship between date and order will automatically convert it into an inactive relationship. As I said, we only can have one active relationship. So what to do? Well, we could create the inactive relationship first, as we've done here, and then use this inactive relationship and make it active within a measure. And that is meant by modifiers. So calculate has the power to make an inactive relationship active. And in order to do this, we can go back to the model here. We need to use another function, which is a so-called useRelationship function. So let's do that. Let's actually right-click on orders table and create a new measure. Tick this option. And then for this, we simply say for the measure itself, we would like to create here our shipping sales. Let's call this shipping sales is equal to. And let me go to new line and say for the shipping sale, this is actually calculate. Again, it's the calculate function which we need. We need an expression. In this case, it's our total sales. So the expression is the same. But this time we're gonna modify, and that's why it's called modifier here, the evaluation, in this case, the relationship. Instead of using the default relationship between the dates table and the orders table, which is based on the order date, we use the useRelationship function here. And let's actually read through it. Specifies an existing relationship to be used in an evaluation of DAX expression. The relationship is defined by naming as arguments the two columns that serve as endpoints. Okay? So what this means is it is leveraging an inactive relationship, and it needs the columns from the both tables in order to specify, okay, what is the relationship I need to make active. So the first one will be from the dates table, the dates, which is this one here. And then the second one will be from the orders table. And on the orders table, we need to search for the ship date. So maybe it's easier to search for ship date here immediately. Okay, orders ship date, like that. And that's basically all we need to specify. Then we can close parentheses here and also close the calculate function. So this now means we use a modifier, which is in this useRelationship, And the use relationship in combination with the calculate function allows us to modify a relationship, in this case, make it from the inactive to active. And if we do that and press enter, we can now evaluate our shipping dates, even though the relationship in the model remains inactive. So for all the other measures you create, the relationships will still be based on the orders table if you don't switch it to ship date in the model view itself. But for this specific measure, the relationship will be used between date and ship date and not between date and order date. Okay? So that's what's meant with when we say calculate can be used as a modifier in combination with a function like use relationship. So if we evaluate that now, if I take the table here and go to our ship date sales, so shipping sales, here we go. Let me tick this option here, and we say these are basically the new values you can see, right? So you see that here in July as an example, we see a total sales number of 34,000 and so on, but actually based on what we have shipped in this month, it's much less, right? So that means we have simply dates for the shipping dates, which have been then maybe in August or even later, right? So that is why there is a difference between those two. So this is based on the order date, and these values are based on the ship date. You can see in total, it's exactly the same. However, there's also value up here, the 26,000 and so on, and this is actually blank here. Why is that? What's the issue here? Well, it is not really an issue. The reason why you can see values here, which are basically here blank, is simply based on the data model structure. Because if I go to the data itself, the data set, if I go to the data view here, and you go to the ship date, which you have here, you can click on this option, and you will see here, there are actually blanks inside. So if I untick everything and go to blank, just to filter the data and click OK, you will see that here, we obviously have, at the end of our data set, we have order dates. And for these order dates, when the order has been placed, actually so far we have not shipped anything. So there is no ship date in place. So these orders still need to be shipped in the future. And that is why a date currently is missing. And that's the reason why you see for all these orders, you can see there are sales here, right? But for the ship date, the value is blank. And so the sum of all these sales with a blank ship date, this is the value which appears up here, this one, okay? And that is why you don't see anything here. That's the only reason. So it's not an issue. It's simply based because there is no actually valid date for this amount of sales so far, okay? But in total, important, this is exactly the same number. Of course, you can filter this if you don't want to see that. Can be done in the visual itself or using the filter pane. It's up to you. But just to explain why there is actually data in here and there's nothing in here, okay? That's the reason for that, because in the data itself, there is so far no shipping date for that. And that's it. That's it, how you can use calculate with or as a modifier in combination with use relationship. So let me actually double click here and name this properly. Let's say modifier for now. Press enter. Then we save the Power BI file and actually now end the video. So thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hey friends, welcome back to another video about calculate, and let's dive a little bit deeper into context transition. Let's have another example for that. We already talked about that. Context transition means that row context is actually applied and gets converted into a filter context, which means that if we have a table in here, like for instance our dates table, that means we always have a row context, which is in this case each individual day, so each row, and this row can be converted into a filter context. This is basically context transition, and calculate is a measure which allows us to do that. And let's actually visualize an example in here, okay? So first, let me actually create a new page and let me name this context transition as an example. Okay, so what I want is I want to have here another table with, in this case, dates column. So I can go to my modifier here, and actually I like to have the same table. So that is why I was Control-Z to copy this, and then I paste this back in here. So to get exactly the same table, and I just remove, in this case, the shipping sales. I don't need them for now. Okay, so let me untick this here, and let's stick to our default table, this one here. Now, let's say we are interested in the sales figures, that is true, But what we actually want is we want to figure out a way how we can calculate the maximum amount for a specific day across all the year-month combinations. So I would like to see not for July 2019 the total amount in this month. I would like to see here what was actually the total amount on the highest selling day within this month. That's what I want. So I actually need to remove this kind of context I have here, and I need to go deeper into my data set and evaluate each row in July and figuring out, okay, based on the days in July, which was the day with the highest amount of sales, and actually what was this amount of sales. So let's do that. At first, I like to create a new measure. So let me right click on my orders table here and select new measure. So click this option, and then let's just wait. And here we go, there's our measure. And now let's actually create the measure itself. So let's say these are our maximum sales. So I call it max sales. And I use a double X. You'll see in a minute why, because we use an iterator function, which is the max X function. So we type in max here, and there are two functions here, actually three, but the max here is simply what is the maximum of, in this case, two scalar values. But we want to use the max X function, which is an iterator function. Remember, all the functions ending with an X in Power BI are iterator functions. An iterator means it iterates over each row in the table you have, in your data table. So that's what we need. We use an iterator. So that is why the first argument will always be a table for the X functions. So the table is the dates table because we want to iterate over the dates table. So we want to go through each row in the dates table, which makes sure that we iterate actually for each day, even though in our current visual, we only show the day and month level. So iterate through all dates, so each row in the dates table, okay? And then we want to apply, in this case, calculate. So because we need to make context transition happen, so use calculate function here. And then we use another iterate function, which is the sum x, not sum y, sum x function, and it needs a table. In this case, we are going through the orders table, so orders. And within the orders table, we want to multiply, in this case, let's say that we have a selling price in here, selling price, and we multiply this by the amount like that. And then I can close this here. So far so good. And then of course I also need to close the calculate function. And finally, of course, I need to close the max x function to iterate over. And now if I press enter for the max sales, let's evaluate this measure and let's just see what we get. Okay, so let me just untick this here, go to the visual, and let's take the max sales. So add it to the visual and let's see what we get here. So for here, for the first entry, we got 4,497. So what is this value again? This value actually now represents the highest or the amount of the highest selling day in July. And we can check this if I go to my Excel file here. I have here sales in this case in this column here. And if I take a look at July in this case, which is here based on the order date, here I got my July data. And on the 9th here, this was actually the highest. If I take a look at this one, you can see here, probably because we got here 3,000, which was actually the highest amount. If I take a look at all these on the other days in July. So if we simply then take a look, this was the 9th, this and this. So we got 3 days in here. And if we simply use all of them and add them together, at the bottom here, you can see 4,497.37. And this is exactly actually the same amount we have here, right? So this number in here. So this formula works for us. And the reason why it works is, if I take a look at the formula one more time, is because we use the calculate function, and calculate function ensures that context transition is happening. So that means that the context we need is from the dates table, each row in the specific dates table, we want to evaluate each, in this case, some x here, each row in the orders table for the specific dates. And this also can also only be done with calculate. So if we, and I'm going to show you this one more time, if we remove the calculate here, if we say, let's say max sales wrong, so let me copy this here, and okay, let's enter here, and let's actually create another measure here, right click, new measure, and now let's paste this inside and say these are the max sales, but the wrong ones, right? So call them wrong, and then I remove the calculate function. Everything else remains the same. I just say I remove the calculate function, then of course I can also remove the parentheses here, and that's it. Beside this, the formula is exactly the same, but now without calculate. And if we do this and press enter, we will see that the context transition will not happening. So that means that it will not evaluate each row in the orders table. And that is why if I use this measure now, the max sales wrong, tick this option, and please follow me here, you will see that you get here actually the same results as in the total sales here. And just by the way, I know sometimes it is a little bit misleading. Why is there a difference, as you can see here and here? The simple reason for this is that in my data set, the sales column, which is currently referring to total sales here, so if we go down to total sales, this one here, the sales column is a little bit different than multiplying here what we've done in our max sales column here, the selling price times the amount. So there's a slight difference. That is why you see differences in here, right? And I can show this to you, or I can prove it to you if I go to my, in this case, max sales, and I use this measure here. So sum x orders, order selling price times orders, order amount. So if I simply use this function here, I copy this, and if I right click, where is it, on my orders table and create a new measure and call this, let's say, total sales 2, just as an alternative, equals to that. So of course, one parenthesis is too much. And that's the formula. Pretty easy actually. We use a sum x iterator function. We iterate over the orders table, which means we go row by row through the orders table, and then we multiply the selling price times the amount. So instead of referring to the column directly, the sales column, we simply multiply the price times the amount. And normally the result should be the same, but in my dataset there's a slight difference. That is why you can see here differences in these values. Okay, so you also see they are not always different. Here, for instance, they are the same, but sometimes they're different. So, and I can check that. So if we evaluate our total sales based on this column, or based those two columns, and then take a look at our total sales number 2, take this option here, and take this option here, that's basically here exactly the same values here, okay? So don't get confused here, I'm sorry for that. That's simply the difference between those columns in here, but here you get exactly the same values as here, okay? So total sales, if you evaluate like the selling price times the amount, then this would be the value you get in here, okay? And here you see that without actually applying calculate, as we've done here, context transition will not happen. And if context transition is not happening, then you get the same result here for the total sales as for the max, which actually you don't want. You want to have context transition, and you only get this using calculate function, as you can hear, right? With the max sales, the correct one, this one here. And based on the beginning of the course, remember, we also evaluated, or I've told you that context transition automatically happens if you use a measure. So what we could do instead of using calculate and sum x orders amounts, because now we actually created total sales number 2, we could do it the same way. So we could say, let's create a new sales, max sales number 2, but this time it will be correct. So I right click on my orders table, create a new measure in here. And then for this measure, let's say here, this will be our max sales, and use the capital X. So let's call that max sales 2, and then is equal to. And now here we say we want to use the max x function. So again, we iterate here over a table. The table will be our dates table. So I'm referring to dates here. And this time as an expression, I will refer to the total sales, which we have created here, right? Remember, this was the sum x based on basically the selling price times the amount. And that's basically it. So it's a little bit shorter because now we do not use calculate and then sum x and so on. We're only referring to the measure here. And measures by default have the calculate function wrapped around them implicitly. So that means what you can see here, total sales, is actually calculate and then total sales. So that's why context transition is here applied automatically. And that is why at the end, if I evaluate this function here like that, and also add it to the table, so make this table a little bigger, and add the max sales 2 in here, you will see that again you get exactly the same values as here. Even though the only difference here between the max sales here actually is that instead of referring to, take a look at the max sales again, doing this completely in here using calculate and sum x and so on, we create instead a measure which has this part here, so this one to the end. This is actually put into total sales number 2, as you can see here. And if we do this, then there's no need for us to also write a calculate, you can simply refer to the measure directly without using calculate, because the calculate will get applied automatically. Okay, so that's another example for context transition, and that's it for this video. So thanks a lot for following along, and as always, wish you all the best and see you in the next video. Until then, best guys. Hello and welcome back to the next video, and now let's talk about the expanded table concept in Power BI with the calculate function. So in order to do this, I have prepared a little Excel file, this one, and you can download it from the resource section, just in case you want to have this too. What you find here is basically all the columns we have in the model. So these are all the columns, and you can see a few of them I dotted. I use a few dots just because there are simply too many of them. But the idea is that I break down here each table we have in the model by the columns. So you see, as an example, we have an employees table here. And within the employees table, we have a name, surname, ID, team, and country. And if we go back to our model, if I take this option here and take a look at our model view here, we have an employees table with exactly those columns in here, right? They're available in here. And the same is true for the other columns. Like for instance, the suppliers table, we have here the 3 options. And if I go back to the Excel as an example, we got 3 columns in here. For the dates column, as I said, I simply did not list all of them because they're a little bit too much. Also for the orders table, which are those columns, but simply a little bit too much. But the idea is hopefully clear. Now you see that each of those tables is part of the model. And important is, if we go back to the model, that we have relationships, right? We have relationships from the one side to the many side. So 1 to star. And that's also the filter direction. That is what's indicated by the arrow here, right? So basically we're using the employees table to filter the orders table, not the other way around. And the same is true here for the dates table. The dates table is filtering the orders table, and the suppliers table is also filtering the orders table. But the tables, like employees table and suppliers table as an instance, they don't have any relationship. So I can't filter the suppliers table using my employees table, or my suppliers table in order to filter my employees table filter the suppliers table. So both options. But this is not available because the filter currently only works from the table above basically to the table below, from the one side to the many side. And this is a little bit indicated, or what I try to indicate here. So we have columns in here for the table, and these columns affect the orders table, because here you can see all the tables: employees, suppliers, dates, and orders. So the orders table is linked to all of them on the many side, and that's why each of the columns from the employees table affects the orders table. And the same is true for each of the columns here from the suppliers table is also affecting the orders table. And the same is true here for the dates table. And of course, if you filter directly from the orders table, so from a column from the orders table, the other columns in the orders table, this of course is also affecting the orders table. So that's the idea behind this table concept here. Now let's actually explore this in here. Go back to our view here and do this maybe with the employees itself. So if I click on a plus symbol here, I will add here a new table. So I will go with my employees. Let's go on here and use the employee names, right? So I'll click on the employee names like that. And then we can see all the employee names, Andrew, Anne, and so on. And let's just make this a little bigger so you can see that better. Let's go to the values section here, and I just increase the text size here to, let's say, 15, not 15. Okay. So we're good to go, and we see all our employees. Now, if we would like to see any kind of measure here, let's go with the total sales one more time. So hopefully you don't get tired, but simply this is the field I have. So I take this option here and I would see the total sales. Now the total sales, remember this, as well as the total sales too as well. They are coming from the orders table, and because the employees table is linked to the orders table, it is filtering the orders table, and that is why we see here the total sales for each employee filtered, right? And here the total sales. So that works perfectly. On the other hand, if we would like to ignore the external filter context, we know we can do this using the all function and calculate. So let's do that. So let me right click on orders table, and let's do this a little bit quicker because we know how that works. So let's say here the total employee sales is equal to, and that's the calculate function. Then we need an expression. We refer to total sales here. You can also use total sales too if you want. Here we use total sales. And then I say all, using the all function as a filter here, and referring to the employees table. Employees table, and there, actually I'd like to see the employee name. This one in here, okay? So I can do it this way. So that's basically kind of similar to what we've done before, but this time I remove the filter function actually and using the all function here directly. So the all function can return a table. We have seen this when we apply filter, because remember, when I put in a filter here, the first argument of the filter function is a table. And we used all the function with a column in the past. So the all function here within the filter returns a table. This is one use case of the all function. On the other hand, if we ignore the filter here and simply use the all function directly within the calculate statement, then this is actually a modifier, like we have seen with the use relationship as well. So this time it's not actually working as a table, even though it helps actually or returns a table here, but it actually works as a modifier. You can call it this way. And this actually works exactly the same. So it means that we want to evaluate an expression, and the modified context here using the all function is simply use all the employee names. Then we can close this parenthesis here, and I can press enter. And if we take a look at what we get as a result, if I take this option here, and let's use our employee sales. So there it is, total employee sales. I can take the option here, and you will see here that we get 1.35 million everywhere. That's exactly what we would expect, right? So far so good. Now what if I'm using now a different column from the employees table just to filter the data? Let's actually do that. Let's go within the employees table. If I scroll up, there's also an office country, right? So I can simply click somewhere on a blank screen, and then I take office country here. Then I would see here the office countries. Of course, I would like to see this as a table for now, so I use those two. And of course, I increase also the size here to 15. So let me scroll down here. Let me just increase the size to 15. So I get UK and USA in my example. So then I maybe like to see here the total sales figure first. Let's actually visualize that. Let's go with the total sales. We would see exactly what we would expect. So total sales broken down by office country. Okay, so far so good. Now, if we now use the same measure which we have calculated here, the total employee sales in this table, what do you think what happens? We used the total employees. Let's actually take a look at the measure here and removed the filter context, right, from the employee name. However, if I take the option, use the measure here in my second table, you will see that I get exactly the same results as the normal total sales. And the reason for this is if we go back to our example here, because using the all function in the calculate, what we did was for our all employee sales, we basically removed the filter from this specific column in the employees table. But since there are other columns in the employees table, like as an example, the office country, the filter for office country has not been removed yet. That means that the office country here is still filtering the orders table, this one. And therefore, if we go back to the here, that is why we see here the split for the two different measures in here, right? So exactly as we see with total sales. So basically the all employees name is ignored because it's simply not available in here. We only filter by office country, and the office country filter is still in place. Now, if we would like to remove the office country, we could of course either use all employees and then employee for the office country. We can refer to the office country column in here, or you could also refer to the complete table. So that means if I go back to my Excel one last time, if I want to remove all filters from the employees table, which might affect the orders table, I can simply refer to the complete table. So if I say instead of all employees, I can remove the specific column, and simply refer to the complete table, like that. And if I do this, then you'll see that I don't only see the 1.35 million up there, I will also see this number down there. If I press enter, we'll see that now the same number appears here. And the reason for this is because now we remove any filters coming from the employees table which might affect the total sales here. No matter if it's the office country down there or if it's the name itself up here. Okay. Now what if we use now some kind of filter, external filter here from another table? So if, as an example, if I make this smaller and this smaller for now, if I go to my dates table in here, and I will use maybe the year. So let's say I'd like to see the year. As an example, there's my year column. I take this option, and I don't want to have this as sum. I simply want to use this as a slicer. So I go with the slicer here. And now you see here, I got my years. And of course, you can adjust the slicer if you want. For instance, a list, if you want to have it like that. Let me just check that. And maybe a little bit bigger. So hopefully you can see that better on your screens. So just a second. Go in here for text size, and let's say 15 for now. So we got our years in here, as well as a blank in here. But currently, let's ignore the blank for now. Now the idea is, what if I filter my data based on the dates here? So if I tick, for instance, 2020, if I tick this option, now we see that the total employee sales get affected here, right? And the reason for this, one last time, I promised, is if I go back to my Excel file here, now we removed in our measure all the filters which might come from employees table, but that does not affect the other tables like this one here, as well as this one. And so if we now use the date here, so in this case the year here, to filter our orders table, then of course the orders get filtered, and it doesn't matter if there's no filter applied on employees, the orders table is still filtered by, in this case, the year column from the dates table, right? So that means, even though, as we go back in here, we have removed all the filters from a specific table, based on the expanded table concept, and that's what it's called, which I tried to explain with the Excel file, we can still apply additional filters from other tables which are connected in the model, and we still get the filtered data back. Okay? So that's it for this video. So hopefully you were able to follow along. In case you got questions, feel free to ask. Otherwise, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hello and welcome back. Now, in the last video we talked about this expanded table concept, and we had a look at this very interesting Excel file, and we basically removed the filter from the employees table, but we have seen that this doesn't matter, because if we use any column from another table, could be suppliers table, or in our case it was the year column from the dates table, we still affect the orders table, as we've seen an example in here, right? So this filter still works. Now what if you want to remove any filters? Then we can simply refer to the all again, but instead of referring to any of those tables, like the employees table here, or the country table, or the dates table, what we do instead is we're referring to the orders table. So the biggest table we have, because if we say the all in combination with the complete or the biggest table, the orders table, this means that no matter what kind of filter gets applied from employees table, suppliers table, or the dates table, or any other kind of table we connect to the model, it doesn't matter, because we simply remove all filters which might be applied in the orders table. And we can easily do this if we go back to the model and say, for our formula, we can refer to one we have already created. So let's actually make this table smaller here, go to the orders table, and what we did in here, we used the total employee sales, so we can actually refer to this measure here and copy it completely, Control-C to copy it, so you don't need to rewrite the formula if you don't want to. And then you can simply create the measure, right click on orders table, new measure, and then we paste this inside. Just a second, there it is, and say employees table, say all employees table, name this for all now, let's say actually all orders table, okay, all sales orders table, like that. And then say calculate total sales, and instead of referring to employees table or the suppliers table or the dates table, which only remove the context from the specific table, we simply remove any kind of filter context, which simply means we are referring to the biggest table we have, and this would be our orders table, like that. And if we do this and press enter and evaluate this, let's actually go into, scroll down, there it is, all up there. If we tick here our table we currently have, and now if I place the all sales order table, so the measure inside, now you can see we got the total amount of sales here for each entry. So let me click this, make this a little bigger, and we see that now not only the employee name as a filter is completely ignored, but also any external filter like the year from the dates table filter is also ignored. So all tables which are connected are ignored, so the suppliers table would be exactly the same, as you can see here, and you get the total amount of sales. Okay, so what if, let's get a little bit further, let's say what if you want to actually ignore all the filters from the model beside maybe a specific column for whatever reason, and there might be several reasons for that, but you want to apply still one filter. let's say in our case, I have, in this case, various categories, and I want to remove all the filters from the model, but I want to keep one filter intact. I want to be able to filter based on my selection of the categories, but all other filters should be ignored. To do this, we can use another function in combination with calculate, so we can refer to the so-called all except function. So let's try that. Let's actually, at first, maybe create a slicer. So we have this already. Tick on the category, and then swap this to a slicer in here, and also increase the size, so we can see that better. Let's go in here, and tick here, maybe the 15, right? Okay, so we're good to go. And make this also bigger, and I think this is a little too big. Make this smaller, we don't need that much space. Okay, so here we got our categories, and of course we can tick this. Currently all get filtered. Beside this, of course, all orders still doesn't get filtered, because this simply removes all the filters we have in the complete model. So what we want is, we want a measure which ignores, in this case for instance, the employee names, which also ignores here the countries, which ignores the external filter, like for instance from the year, but which still considers this filter we apply here. So let's do that. Let's actually right click on the orders table and create a new measure. So here we go, there's our measure, and then say this will be our total sales except, in this case, category. Okay, like that is equal to, and let's go to a new line, shift enter, and then I say here I'd like to actually calculate something. Remember, we need to definitely modify the filter context, and whenever this is the case, we need to have the calculate function. We need the expression, so here I will be using total sales, and then I need a filter context. And this filter context now is using the all, and you can see there's an all function, and there's also an all except function. So all except, we're choosing this function here, and then we can give it a table here. Now the table itself, from where actually our filter, which we still want to take into account, comes from, is the orders table in this case. And from the orders table, the column name is the category. Here we go. Now I can close parentheses, and you can read again. I always encourage you to read through the explanation here. So it returns all the rows in a table except for those rows that are affected by the specific column filters. And that is exactly what it does. So it removes all the filters from the orders table, but it keeps the filters we specify here. So here you have column name 1, but of course you can put in a comma here, and then you can refer to column name 2 and so on, if you want to add several columns which you still want to keep into account when you filter. For now, I need only one. I close parentheses here, and then I also need to close the calculate function. Now I press enter, and I got my total sales except category. So far so good. And now if I also add this to my table, so let's say to this table as well as to this table, let's do it to both of them. Where is it? Simply search for except. So except, here we go. I can tick this option here. So I got it in here, and I also select this table and also tick the option here to have it in here as well. Let me drag this a little bit to the side and make this a little bit bigger so we can see that. So you see that this measure itself, so sales except the category, is not affected by the employee name. That's why we see the same value here. It is not affected by the office country. That's why we see the same value here. And also it's not affected by the year, because I can select any kind of year and nothing changes here as well as here. But what if I now choose one of the categories? So let's say I'd like to see cookies. I click on cookies, and we see that the total sales except category is actually affecting by this, right? So we can see here 101,000, which is repeating here for all the employees as well as for the office countries. So that means even though we remove any kind of external filter context, because we used here the all except and referring to this specific column, this means that the context from the column itself, in this case desserts, drinks and so on, what we select is still applied. The filter is applied and it works properly, exactly what we want, okay? So that's how you can use the all except function in combination with calculate. So we have used now the all function, we use the all selected function, and we use here the all except function. So these are all modifiers which are often used in combination with calculate, and hopefully now you understood what they do and how they work. So thanks a lot for watching, and hopefully see you in the next video. Until then, best guys. Hello and welcome back to this video about modifying with the calculate function. And in this last video, I'd like to refer to the time intelligence, because calculate is also very often used with time intelligence actually. So let me first rename this page here to, let's call this expanded table. Okay. And actually I used capital letters, so let's actually expanded table do that here as well. Okay, just to be consistent. And finally, I'd like to actually add a new page here, and I double click on this and name this page Time Intelligence. Time Intelligence. And here I have to say, with time intelligence functions, Microsoft has done a great job for all of us, because it has really made time intelligence quite easy using the built-in functions which are available for us. Just as an example, if I go back to my, let's say, the context transition, because I want to copy the format here. So let me actually Control Z to copy this, and go back in here and Control V to paste it. And I will remove a few of the measures which I don't need. So this one, this one, this one, and this one, okay? This one as well. So we got here our year-month combination, and we get our total sales figures in here. And now if we would like to know, for instance, what is the total sales in the prior year, there are various options. We can use the same period last year function or the date add function. Just an example, let me use the same period last year function. You know how that works. So right click here, go to new measures, and let's say total sales last year. So I'll call this total sales last year is equal to, and now I can use calculate. Again, we need to have a modifier expression here. We refer to the expression itself, which we want to modify, which in this case is the total sales. And then as a filter, we can use the same period last year function. And as I said, you can also use date add function if you want. But as an example here, all we need to do is we refer to same period last year and put in then our dates column and there the continuous date column, like that. We close it and close it one more time, and we are good to go, right? And you see how easy it actually is to use it. But this is what I said, or what I meant when I said Microsoft has done a great job for us. Because what actually happens with the same period last year function, this is only sugarcoat. This means under the hood, this actually gets converted into what we have seen before, something like filter, and then referring to our dates table, and then a more complicated measure just to ensure that only the dates from a prior year are actually are filtered in this table and then used or applied to the total sales. So always remember the second argument here, which is the same period last year function. Let me remove this for now. This actually is returning a table. And this table is filtered based on, or the dates table is filtered based on what we have currently in the view, which in this case would be, for instance, 2019 August, and is simply reverting then 1 year back. But this happens automatically using calculate, because it modifies the expression, and also the same period last year function, which under the hood gets converted into something like filter the dates table and then actually returns only the date range which is relevant, so the prior year date range. But it is returning a table again. And using same period last year function is much easier than writing this filter expression on your own, right? So all you need to do is now you press enter, and then you would actually be already done with creating the measure. Because all you need to do is go in here and then remove this filter we have here, and referring to the LY, so last year, and there is total sales last year. I can tick this option here and I would see the data, right? In July 2020, I exactly see the values from July 2019. And of course in 2018 I don't have any data, that's why this is empty. And maybe just to practice this, let's do one additional time intelligence function, one which is often used, which is the moving annual total, right? So sometimes you want to see like a cumulative sum, but shifting, right? It's shifting always, that's always 1 year behind, right? So this moving annual total is often called in companies. So in order to do this, let's actually move this filter for now, right click on orders table, create a new measure, and let's say we want to use here the moving annual total, so call this mat sales, moving annual total sales is equal to, let me go to a new line here, and say I want to calculate something, so calculate. And by the way, you can press the tab key if you want to just get like that, right? If you want to put like that, could also be done. So calculate, and then what I want to do is I want to refer to a measure, total sales, so measure, and then I'm referring to the dates in period function. Again, a great function which is really flexible and easy to use, right? But it returns a dates table as well. And this dates table will be then, after evaluation, it will used and applied on the total sales, and then basically calculate, does its magic, and returns the correct values in the specific dates period, which define here. So we can give it a dates, and we return to the dates table, the date column, and then we need to just specify a start date, and then actually the end date. So the dates and period here for the start date here will be simply the max. We need an aggregation, so we can refer to the dates table date again, like that. And then we can give it the number of intervals, which will be -1, and then the interval itself. As you can see here, you have day, month, quarter, and year, and I'm referring to the year. Then I can close this parenthesis and also close the calculate function, and we are done. So quite easy again, because the filter context here, or the modifier itself, so writing this one here expression, is actually done from Microsoft already for us. Simply, we only need to refer to the dates and period. And then we can press enter, and can evaluate the formula, and we can now use it directly in visualization. And of course, you can use this in bar charts, any other kind of visualization as well. I always use a table here for explaining calculate because I think that's the easiest way to understand it, to see it visually. So let's go with in this case, the MET sales. There they are. If you tick this option and also display it here, you see it starts with the same value here. Then it adds up the first 2 months, the first 3 months, and so on, right? So it continues to accumulate to show the total sales amount. But then here as an example, in July 2020, it takes basically the 51 into account, but it removes then the 34,000 and so on from July 2019. So you always have a rolling 12-month period, if you want to call it this way, right? To go along here. Okay, and that's it. That's how you can use time intelligence functions in combination with calculate. And there are various more out there, but this is just an example how you can use them, okay? So that's it for this video. Thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hey friends, welcome to this video. Now here I'd like to dive deeper into custom visuals in Power BI. Now, so far we used a lot of the default visuals which are available, which you can find here in the visuals section, of course. And most often those visuals are probably enough to create a great report. But sometimes you might need to have additional visuals which are not there by default. And then one of the options you have is import custom visuals. Now if you're logged in to Power BI, you can directly import them from AppSource by either clicking on 3 dots here and click on get more visuals, or of course also inside the home tab there's also an option more visuals, and then go to from AppSource. AppSource is just the free store from Microsoft where a third-party provider can upload visuals and you can use them for your own reports. Now, if I click on the 3 dots, let's do that, and get more visuals, we can import the visuals. So let's say, in this case, I'd like to show you 4 different visuals. But you already see, just to mention this, that there are tons of visuals which you can choose from. And I encourage you, if there's something you need, feel free to take a look at that, and I'm certain you find something very interesting which might help you enhance your reports even further. You can also filter them here, as you can see, because there are various, let's say, subcategories you can choose from, so that might also be helpful, or you just use the search bar up there. If your organization has visuals already provided for you, which should be used, then you can also click on organization visuals here, and then you will find them here. So AppSource visuals then again is referring to only the ones which are available from AppSource, which you can download. Some of them are for free, others have so built-in additional features which you would have to pay for. But let's actually explore a few of them now. Click on all visuals again. So let me first import the Aster plot. Let's search for Aster. You see there's an Aster plot which is created by Microsoft directly. So no third-party provider, but Microsoft. You can also see a rating, and if you click on it, then you see here a preview. You can also read through it, what it does actually, and you can also click on ratings and reviews to get more insights and additional information here. For instance, here you can see that the pricing is for free. You also see here that is PBI certified, which might also be an additional help to identify whether you want to use this visual or not. Now, if I click on add, take this option, then the visual gets downloaded, and you can see that now it's imported here successfully. If I click OK, you'll see that now I could use this visual by simply clicking on the Aster plot. Let me maybe import 3 additional visuals and then import some data in order to show you how they work. So again, I click on the 3 dots here, get more visuals, and then I'm searching here next for the Sankey chart. So Sankey is also a very interesting chart, often used, and people like it a lot, so let me show it to you here as well. It's also provided by Microsoft, even though if you take a look at the rating, probably the rating is not the best, but let's explore that, and then of course you have to figure this out for yourself. Again, the great thing here, it's completely free, so there are no limitations regarding these visuals, no in-app, let's say, purchases available. If I click on Add, and I just wait, and you can see that it's also downloaded here directly. I click OK, and then let's import 2 additional ones, which is the radar and the chord plot. So let me click on here, get more visuals, and then choose here radar. There it is. I tick this option, and this is also provided by Microsoft. I click on Add. Now you can also see again a preview here, what this looks like, and you might already have an idea when this could be helpful. Let's click on Add, and then it's also available in here. And finally, of course, the chord plot, because these are the 4 data sets I've provided for you, which you, by the way, can download from the resource section. So let me choose here the chord, search for chord, and that's this one here. And also this is provided by Microsoft. I click on Add, and then it is also imported and available for usage. Now, one additional thing here is the following, and that's very important. Those visuals here are now pinned to this specific report. That means if you open a complete new Power BI file, then those visuals would not be available. If you want them to be available in all your reports, then you need to right-click on a specific visual and you click on Pin to Visual Pane. If you do this, if I do that, you see that now it's not there in a second section anymore, but it's added to my default visuals in here. And I can do the same for the other ones. Simply right-click here, click on Pin to Visualization Pane, and this means that those are now available in all my Power BI reports. So whenever I open Power BI, then those visuals are already included. If I want to remove them, I can simply right-click here and say Unpin this visual. And if I do that, you get here the warning that you're about to remove this visual from the visualization pane. To use this visual in other reports, you'll need to import it again. So that's also here the message and identification that if you want to keep them and use them in several reports, just right-click and pin them. Okay? So let's now actually import the data. I will click on Excel workbook here and import here the plots, this one. I click on Open, and then we have here 4 tables, which is Aster plot, chord plot, radar plot, and Sankey plot. So I named that already properly, and I can click on those tables here, and you see they are quite easy tables because the main goal here is really to show you what these visuals can do and how they work. So let me click on the other 2 ones and then click on Load because there's nothing we need to prepare. We can load them directly into our Power BI report. So just wait a little second, and there they are, and we got our tables. An additional thing I'd like to highlight is because some of the names of the columns are same between those different tables, Power BI might create relationships for us. Let's take a look at the model view, and this is indeed the case. As you can see here, there's a relation, for instance, between the chord plot and the Sankey plot, simply because here they have both end as a column name. But these are completely separate from each other, so let me right click here and let me delete those relationships. So we do not get any issues right here. Let's also delete this one, click OK, and now we got simply 4 different tables which are not linked in any way. So far so good. Okay, so let's actually go back to the report page and let's have a look. Now for the Aster plot is this one here. So click on it, then it's available in here. And let's say here we have actually only 3 columns, which is the task itself. We have a revenue and we have the hours. And what the Aster plot can do for you is simply you choose a text column. In my case, it's the task here. And then you need some numerical columns, in case revenue in hours, in order to visualize the chart itself. The chart is kind of similar to the donut chart, but it gives a little bit additional information because we can actually add two numerical fields here. So for instance, if I click on revenue, you see that now the chart gets created, and I can see that, for instance, here, the revenue for development here is the biggest. But what I do not see is, in this case, currently the hours which have been worked, which is also a column in this dataset. And also, if you take a closer look, you'll see that here, right now, all shapes have the same size regarding the donut itself. I mean, this is higher, but the size itself is the same as the other ones. And this is how we can add here a second numerical dimension, which in this case is hours. We can also drag it to the y-axis, drag and drop it, or you simply click on it. And now you can see that the ranges here within the donut chart itself are different. So you can see here it's the biggest revenue, but also the most amount of hours. So it increases the space here, while this, for instance, tableau here is revenue much lower and hours also much lower. And of course, this can be customized further, the same way as other visuals. So if you click on the Format Your Visual pane here, you see here various options, like let's show the legend, tick this on, and we can see here the legends for different kinds of tasks here. We can also click on Center Label, then this would mean that the task label appears here in the center, because this is simply the header. And of course, you can increase here the text size and do other things here as well. So if I press enter, you can see, it's actually, let's say, maybe 20, see that better. And you see that the task is now bigger. And also it makes sense probably to click on here detail labels, simply to show the specific labels. And again, click on here and then specify display units. What exactly do you want to change here? And maybe also you want to change different kinds of pie colors. You can do that here individually if you want to do that. Of course, you can also change the color. You all know that if you go to the view pane and then choose maybe a different here, a theme. Like for instance, click on the city park here and you see that now the color is completely different. But this of course is up to you and maybe your corporate identity you currently have to follow, right? And your specific guidelines. So that's actually it for the chord plot here. I personally like this plot because I'm also a fan of the donut chart, but this gives you even more information because we have also a size component to it. You can use it, you don't have to use it, but it's just here a proposal what's available in the app source. And as you've seen, there's much more you can use. Next, let me show you the Sankey chart. The Sankey chart is quite interesting, and as far as I know, a lot of people like this chart, but in the past it was pretty difficult to build, also in other data visualization tools. But here in Power BI, it's really easy, because you simply click on the visual, and then of course you need to have some data for this specific Sankey chart. Now, the data itself is quite easy, because what you need is, you need a start, you need an end, and then you need some kind of numerical dimension in order to specify how big actually the different kinds of lines or bars are. So here you see you need a source, a destination, and a weight. So for instance, you could use a Sankey chart to show the development between 2 years. So from starting 2021 to the end of 2022, for instance, and then you want to visualize some kind of development. This, for instance, could be use case for the Sankey chart. In this case, I simply, if I add start to the source, drag and drop, I add end to the destination in here, then you already see that the Sankey chart has been built. So here I simply used a few names here, for instance here regarding different kinds of companies like Apple here, and you see a flow from Apple to some of its competitors here, for instance. And then here you see, for instance, a flow also from Power BI then to other tools here, for instance, right? It's just an example here, right? Because most often, of course, people come from Tableau and then they go to Power BI, the other way around, of course. So now here you see that the bars, that's what I meant, are currently all the same size. But normally you want to actually also increase the size or decrease the size based on a certain numerical figure. And that's why I have amount in here. So I can add amount to the weight here. So if you drag amount to the weight, then you see that now there's a flow from, in this case, Power BI here, for instance, to Python, to development, and to Tableau, or from Apple to the different kinds of other companies in here. And you see exactly that the bars here, or the flows, are in different size based on the number we have in the amount. You also have the data. So if you want to look at the data, just to show you this briefly, for the Sankey chart, for instance, that's what it looks like. And the reason why we have Power BI in the middle is simply because I specified here Power BI flow from start to these three tools, but I also have Apple at the beginning, and Apple flows to Power BI. This is why we have actually in the report this development from Apple to Power BI, and from Power BI there are various flows to the next one. So that's how you can build them, just in case you're interested. This of course requires you to shape your data in the specific way. But if you do this, then you see that it's really quite easy to do, to visualize the chart like that. And of course, this can also be customized if you go to the Form Visual, and then you can explore exactly here what actually do you want to show. Data link labels turned off, you can turn them on, and then you would see this. Of course, you could also go in here and then customize the text size and so on, right? So here I just encourage you, if you're interested in this visual, if you want to use it, then just download it from the store, from App Source, and use it with your own data, and then of course play around with all these options which are available in here. So the other two visuals are at first, of course, here the radar chart and then also the chord plot. So let's explore the radar chart. Let's take this option here and take a look at the radar plot in here, and maybe also a quick look at the data. So just in case you have not done this already, when you download the Excel file, you see that basically all it has is a task, and then it has a target and an actual value. And if we go to the report view here, and then you see you got a category here and a y-axis. So you put basically the task you have on the category, then you have it here, and then you can put the, where is it? Oh, sorry, not from the ESP plot, from the, where is it? The radar plot. You put the task here to the category, like that, and then you put in the actual value to the y-axis. And if you start like that, you see that now, okay, you have now here, for instance, a person or anything, in this case a task you want to analyze, and then you see here the different kinds of, well, traits regarding this task. These are the actual values in here, right? And if you want to compare then those actual values to target values, you can quite easily do this by simply dragging then a target value below on the y-axis like that. And if you drop them, then you see here actual and target, and you see whether you achieve the target or not. So that's why, or that's where actually this radar chart can be quite helpful. Of course, you probably want to go to the formatting pane here as well and take a look at the data colors, because most often you probably want to use different kind of colors in here, right? So for instance, for the target, something maybe a different color. Let's try out blue here, and then you see here different kinds of colors in that, right? So that's how basically this chart works. And I think there are probably use cases for using this, and you've seen it's for free. You just need to download it from the store. So if there is some kind of use case now or in the future, you know now how to use it, and that can also implement this in your report to enhance your report even further. Finally, I'll show you one of my favorite visuals actually, which is the chord plot, which also shows, developments over time, like the Sankey chart. So if I select the chord plot here, tick it, and then let's go to the chord plot, the final data set. Again, the data set is quite easy, so it's easy to understand. You got a start and end and an amount, and it's also from, to, and values. So kind of similar to the source and destination and values what we have in the Sankey chart. Maybe the name was different, it was weight here, but actually the data structure is exactly the same. So if you tick this option here and say from, well, for the chord plot we have a start. I can click on start here and drag it from to from, and then I'm using an end and drag it to like that. And then of course we need to have some kind of numerical data again. So here I have an amount one more time. I drag this to the value section, and then you see here the development here. So meaning, for instance, someone, and that's why I think this chart is quite interesting, because you see exactly where did the people stay or did they move, for instance. Here I could say, for instance, a lot of people here moved from, in this case, from Tableau, for instance, to, in this case, development, or from development here to Python, or from development also to Power BI, right? That's how you can read this this chart. Or for instance, a lot of people who used Power BI also stayed with Power BI here, for instance, right? These are the ones, the shapes which remain in the same color. And that's how you can read from this. So that's how this chord plot works. And same as the other ones, if you take this option and go to the formatting options, you find here again specific options to choose the data colors, the axis, the labels, and so on. So these are a few visuals from the store which you can use for free. So of course, the only thing which is required is if you use this in a corporate environment, then make sure that your IT admins allow using those visuals. But of course, it's probably much easier to use a visual if it's certified by Microsoft, which are all of them, as you have seen. So that's it for this video. Hopefully that was helpful and give you some ideas on how to enhance your report even further in the future, just in case you need a specific visual which is not available by the default visuals. So that's it for this video. Thanks a lot. Please try it out yourself. The resource, so the 4 tables are available in the resource section for you to download. And if you want to explore further visuals, then feel free to do so. So thanks a lot for watching and hopefully see you in the next video. Until then, best guys.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hey friends, welcome to this video. Now here I'd like to show you how easy it is to publish your report to the Power BI service. By publishing, I mean that after you have created the report, after you've worked so hard to shape your data, to clean your data, and then to visualize your findings in order to create value, then of course you want to share this report with your audience. So with your superiors or your colleagues or whoever. And in order to do this, you want to then simply go to Home, and under Home, there's a Publish icon. Publish means sharing, and you can see here, you publish the report online in the Power BI service. In order to do this, you need to log in and of course have or create an account in Power BI. So you can create a free account or you can use Power BI Pro. And this has certain kinds of limitations if you use a free account, because then you will not be able to share your data securely. This is just one of the limitations. There are a few other ones, but probably if you work with Power BI in a corporate context, then you probably have a Pro account. So you can publish it here to the cloud. So click on Publish. And all you need to do then is simply select the specific workspace. You can scroll down if you search for a workspace, or you click on My Workspace, which is your personal workspace, which everyone has. And then if you click on Select, you can simply publish the report, and you see that now the report is published with the same name into the service. Just a second, it takes a little bit of time by uploading the report to the internet, to the cloud, and you see that now it's successful, and you can simply click on it simply to go to the report in the cloud itself. So you see that now it loads the report here. I'm here in app.powerbi.com, and there is also an ID for the specific report, and here is the report itself now published on the internet, and now I can share this with my colleagues, for instance, and other people, right? And of course the interaction is here also given. So meaning if I click on something, you still see everything filters. So there are no limitations in here. Okay. You also see here the pages. So you also see each individual page of the report. So if, for instance, if I click on here, you see what we have done with the time intelligence. If I click on customer classification, you can see these as well. By the way, if you do not want to show them, but still have them in your report, what you could do, if I go back to my Power BI report here, you see that I can also right click on each individual page and I can click on hide page. So if I do this, if I click on hide page, let's say for DAX or no DAX, now you can see here is a little hidden icon. And now if I publish this again, click on publish. Yes, I want to save the changes first. So that's hidden. I select my workspace again. I select it. I publish. Yes, I want to replace the data set. That's what you've been asked when you upload it again. And just a second, and we wait until the report is uploaded, and then we can view it, and we see that then DAX or no DAX is not visible anymore. Let me click it, and let's have a look, and take a look at the pages here. And now you will see here there is no DAX or no DAX anymore. So this page is gone, concerning the first one which we uploaded here, which was this one, which had this still in place. But this is overwritten now. This is just because it's still in the cache. but you see that the new upload here does not have this specific page anymore. So you can also specify which of the pages from your report do you really want to upload to the service. And that's it actually for Power BI service. So you have seen that the upload is quite easy, but then of course in the service you can do much more. So that's it for this video. Hopefully that was helpful. As always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys. Hey friends, welcome back to this video. Now here I'd like to show you 2 additional ways how you can create your own date tables in Power BI. Now if you remember, during the course we used the M code quite extensively to create date tables. And I also told you that you can reuse this M code all the time. So if I click on the plus symbol here, and if we take a look at our current M code, so the dates table, we can go to transform data here, and then we also see within the dates table itself, which we have created, which was this one here, contains all the dates for 2020 in my case, up to 2022. Now what if you like to modify this? Well, it's quite easy, because actually if you open the Power Query editor like that, you can simply modify it here. Because you see that here it's 2020 1/1, so the 1st of January, and it ends at 2022 12, and then 31st, so the last day in 2022. Because this is what my current dataset comprises, right? 3 years. But I can simply modify this here inside my dates table, which has been created with the function, and I can simply put in 23, for instance, and then the dates table updates. So this can be done quite easily. But still, of course, it's kind of static. I agree with that. So what if you like to create your dates table in Power BI using DAX instead of the M code? You can do that as well. So let me actually click on close and apply, because we have not modified anything here, and then let's have a look. Now, in order to create a dates table in Power BI using DAX functions, you need to be aware of the following. As the name implies, we create a dates table, meaning that we can't simply click on new measure here. Instead, we go to modeling, and then here we create a new table. So as you can see here, we write a DAX expression to create a new table. So similar, remember when we used, for instance, the filter function or the all function or all selected function, these are all table functions. And the same is true for, in this case, the calendar functions which are available. So if I click on new table here, then I can see here my table. Let me just zoom in so we can see that better. Okay, here we go. And now I could say this is my calendar. So let's specify calendar is equal to, and there is a calendar function actually. So calendar, this is the first one. The second one would be calendar auto. But let's start with the calendar function. The calendar function needs a start date and an end date, and then returns a table with one column of all the dates between start date and end date. So again, it's a continuous range, so there are no gaps, which is compulsory to create a proper dates table. So let's get that started. Using the start date, well, how can we enter a date? We could use the date function for that. So you could say date, and then in date, it needs a year, a month, and a day. So I could specify this, for instance, like the year is 2020, there's where I want to start. The month is then, let's say, the 1st, and the day is also the 1st of January. So if I close this, then I have created a start date, and also start here from the 1st of January 2020. So then for the end date, I can do something similar. So I could type in date and then 2022, and then the 12th, because it's December, and then the 31st. But this also would be static. Or I say, I like to have a calendar which automatically adjusts to today's date. And to do this, I can leverage the today function. Because in Power BI, there's also a today function, as you can see here, which gives you today's date. So in order to extract the year, the month, and the day from today's date, I could this also wrap in the date function. So I could say date, and then I say for the year, I want to use the year function. So year from today, like that. And then for the month, I will use the month. There's also a month function of today's date, today. And close this. And finally, there's also, of course, the day function. So I can use the day from today. Today, need to spell it correctly. Okay, like that. Close this, and then also close the a calendar here. And now we have specified our start date, and we also use a dynamic end date here, because this will update always to today's date, also in the future. So if I press enter here, and now you can see we have created a new calendar, which is here. I can select it. I can also take a look at the data view, and you see here you got a unique list of dates in here. Currently it's formatted as date time, so it makes sense maybe to format this correctly, but you see that basically it contains all the dates starting in, let's take a look at here. There's the dates table, click on date here, and you see we got all the dates. Let me actually maybe make this bigger, and then we scroll down. So we see we get started in 2020 on the first day, and if I scroll to the end, to the bottom here, a lot of scrolling here, but you see that this ends on the 31st of December in 2021 in this case. So because this is today's date for me, okay? So tomorrow is the new year, but this basically contains, as you see here, all the dates up to today. So if this is what you need and what you want, you could also use the calendar as you've seen here. The other option would be to use calendar auto, as you have also seen when I typed in calendar in the formula bar. So if I say again, go to modeling here, and I say I'd like to create a new table, click on new table. And then I specify here, this is my calendar, let's say calendar number 2, because I can't give the same name twice, is equal to, and then I'm using the calendar auto function. So calendar auto, and I can specify fiscal year if I want to do that, but you see it returns a table with one column of dates calculated from the model automatically. So the idea is that I can close this parenthesis here, press enter, and then what should be the case, not always what I've found, but should be the case, that the calendar 2 here with the calendar auto function, you should also go to the model, and then you could link the calendar. So calendar number 2, let's just see where it is. There it is. Let me actually zoom out maybe a little bit and drag this to the right to connect it to the model, because currently it's not connected. But let's actually connect this to the model. So for instance, to the orders table here as well. And if I just take a look at the order date here, the date here, let's just zoom in. So I'm connecting the date to the order date here for this table. And now you can see you got a one-to-many relationship. And now if I go back to my report view here, and I would try to take a look at the calendar number 2, so this date, let me also take it here and visualize this as a table. And now you also see it gets started from January 1st, 2020, because this is also what our data model covers, right? Starting in 2020, that's why January here is covered. And if I scroll to the bottom, let's just see 21 and scroll down, 22, and it goes down even further to 23 here. So that's what I meant. For some reason, sometimes it works exactly, sometimes it does not work exactly. In this case, it does not work exactly, because you see it also covers 2023 data, which is actually not the current range. This is why I wanted to mention it, but for me, sometimes it does not work, as you can see here in this case. So you can try it, but it's up to you. The other way, as you've seen, is simply use the calendar instead, which can also get you maybe up to today's date always. So these are the two other functions. What function should you use? So should you use the M code as I recommended at the beginning of the course, or should you use one of those functions here at the end? Of course, this is up to you. What you should be aware of is that the default calendar functions, like this one here, only contains a single column. You've seen that in here, if you go to the data view, calendar 2 as well as calendar only contain the date column, which is the most important column when it comes to time intelligence. This is true, but you do not get these additional benefit columns, which are created from the M code directly. Like for instance, if I take a look at the dates table one more time, we had here the year extracted, the quarter number, the month name, the day of week name, and so on. So a lot of additional information which you can use in order to slice and dice your data. You could also extract some of those columns. Remember, for instance, the year function, and add those columns to your calendar here, and have then here also maybe a second column, which is then the year of date, and so on. So you can create with DAX formulas also additional columns and create your own dates table in DAX as well. So that's possible, that's true, but still I think and I prefer in my setups and in my Power BI work, I prefer actually using the M code because it's quite extensive, gives me this additional information. And as you have seen, you only need to go to home, you go to transform data, and then you just modify here the query parameters. If I select the dates table here, okay, I need to adjust 1 year, 1 month, whatever, and I can do that here quite quickly. Okay, so that's it actually for the date functions in Power BI. So if you want to use them, feel free to do this. Hopefully this video helped you and now you know how to use them properly. So that's it for this video. Thanks a lot for watching and can't wait to see you in the next video. Until then, best guys. Hey friends, welcome to this video. Now here we'd like to dive deeper into the difference between the sum function and the sumX function. Why? Because this is actually a question which always or very often arises during Power BI interviews, but also it's very important to understand the difference. We used the sumX function quite extensively during the course, and we already know that this is an iterator function. Also, please note that for this example, I'm using this Power BI Advanced training, which we have used in part of the course, and I'm using the same dataset. Remember where we had different kinds of sales tables and we had to combine them first. Now, in order to calculate something, for instance, we said we calculate the total sales in here, which is this one. And in order to do this, what we used was the sumX function, because we iterated over the sales table and we calculate here the quantity times the price. And then we derived the correct, in this case, result. So I can tick this total sales here. And if I visualize it as a card, let's do that. We can see it's here 25.66 million. Or to be more precise, let's actually go to the formatting option, go to the callout value and make sure that we see it without any abbreviation. Let's see the real value up to the last digit. This is it, right? So far so good. And this result is actually correct. Now, we could also have thought, well, if we don't use the sumX function, we could use the sum function for that. And because what we do in order to calculate the total sales, remember, was quantity times price. So we could say, right click on the measures table here, create a new measure, and let's do it the wrong way. Let's call this, let's zoom in first. Let me go in here, let me zoom in, and let's call this, for instance, total sales wrong. And then equals, and now instead of using the iterator function, we simply say we want to multiply here the sum of, in this case, the where is it? The quantity, here it is from the sales table, and we simply multiply this here by the sum, here sum of, in this case, here the column name would be here the price, right? Price, where is it? Price. So sales, and there's a price column. There it is, like that, okay? So we could do that and think this is also the same. So if we evaluate that, okay, obviously there is no, this is not wrong to calculate this way, right? I mean, there are no syntax errors at least. So let's actually see what we get here with total sales wrong. Let's actually select this, tick this option here. And well, of course, here as a bar, we don't see too much. So let's go with the card. And of course, let's also see the real callout value without any, in this case, display units. So remove them, and you can see this number is quite high. Also, of course, you can format it just to see it maybe a little bit easier. But even though you see that this number is way bigger than this number here, right? So, I mean, if our total sales would actually add up to this number, that would be awesome. no question about that. But you see that there's a huge difference, and this number can't be right. And what actually happens when you use the sum function like that from the sales wrong? If we go on here, well, what happens is exactly what you would expect to happen. What Power BI is doing here is simply summing up the complete sales quantity column. So all the entries in this column will be summed up first. Then this value would be multiplied by the same for the sales price column. So you multiply the sales price column, and then you also have exactly the sum of the whole column, and then you multiply those two. And this, of course, ends up then creating this huge number. Now you could also think, well, can I maybe try the following? Can I actually maybe remove this and multiply this together in here, like that, inside the sum function together? But you see that this is not possible in Power BI. So Power BI doesn't allow that. You can also wrap one column. You can only wrap one column in the sum function. So obviously, these options do not work. So that's why we need to iterate to do this correct. Because remember, we just evaluate that for now, that's fine. And let's go back into our, in this case, data view, and let's take a look at the sales table itself. So you see that for the sales table, what we really need is we need to multiply the quantity times the price for each row individually. And only then, if we sum up the results of all those multiplications row by row, only then we get the correct result. And this is exactly what the SUMX function is doing. Because all the x functions, or in this case the SUMX functions, are iterator functions. Meaning for the total sales here, they iterate row by row through the sales table. This is why the first argument in an iterator function will always be a table. And then you evaluate this expression inside the row for each row in the table. And that's how we get the correct result. So, can we use the sum function at all? Actually, yes, we can use the sum function, but this really depends on how the model is structured. What I mean by that? Well, let's actually go to the data view here. And let's actually select the sales table. And here again, you see that we already, during the course, calculate also a total sales column, which is already the multiplication from quantity times price. So what we could do is we could here also create next to the total sales column a total cost column. But let's actually create another total sales column just to show you that you can also do it directly here using DAX. Because this total sales column here came from our modification inside the Power Query editor. So let's say inside here we are in the data view, we are here under table tools, and I can say I want to add a new column. So add a new column, but this time not using M, we are not in the editor, we are here in the front end, so we can use the DAX, normal DAX code. So I could say here, okay, I want to multiply, in this case, let's say these are total sales and call it DAX. DAX is equal to, and then simply say this is the price here, price from my sales column here, and I multiply this here by the quantity from the sales column. I can evaluate that, I press enter, and then you see these are total sales DAX, and this gives us the result. Here, exactly, quantity times price. And this expression will be evaluated here for each row individually. So this is the correct result for the total sales. And I can do the same for the total cost. I could say, okay, I'd like to create here a new column and then multiply the quantity times the cost. But to do this, I need a helper column here, right? Because remember, or actually use the related function directly in here, because I can't reference the cost because they are not part of this specific table. So what I could do is I could go to new column here. And then for this expression, I say these are total cost DAX is equal to, and I say this is the quantity. Again, it picks up the quantity from the sales table, so the current table we are in, and we can then multiply this not by the cost. You see, this is cannot be found, but we can use the related keyword, and then we can go to the product table and search for the cost there. And actually, that is the column here. I can close this, and we are good to go. I can press enter, evaluate that, and now I also have calculated here the cost. So this here, this multiplication for the total sales as well as the total cost, this is happening row by row. This is simply an additional column we add here using DAX expressions. And if I go to my report in here, and now let's actually visualize the total profit first. Here's our total profit, the original total profit, which was derived by total sales as an iterator. Remember, total sales was an iterator using some X function. Total cost in here was also an iterator using some X function. And this derived, the total profit here is simply the difference between those two measures. And we got a value of 8.34 million, or to format this correctly, let's actually get rid of the display units, click on none. We see that 8.343 million. And now let's actually use our two columns we have created in the sales table here. So total cost DAX, remember, and total sales DAX. These are the two columns we have created ourselves. And now we could simply say the total profit. So let's define here a new measure, and say, let's say total, let's call it total profit columns, or let's say DAX, is equal to, and now I say this is my, in this case, total sales. And here, where is it actually? Oh, sorry. What I meant is now the sum function, right? So sum, and now I say total sales DAX. So this one here, and we simply subtract here. So minus sum of, in this case, total cost DAX. So this. And you can see here we use twice the sum function for these specific columns. I can press enter to evaluate this measure, and let's have a look. Let's actually go in here, total profit DAX, click on it, and then let's also go to the card visual, and then also go to the formatting option, call out value, and this time remove again the auto feature here to see the exact value. And maybe you would like to format this also as a dollar symbol here first. Okay, and you see that we got exactly the same value for total profit DAX as we get here for total profit. Even though this time, as you can see here, we're using the sum function twice. We simply subtract the two columns. And this works because here it does not really make a difference whether we do it on a row by row level or we do it on a column level. So meaning first sum up the columns for the total sales, then sum up the, in this case, the cost for the which appearing, and then simply subtract them two in order to get the total profit. So that means the sum function is not completely useless. So don't get me wrong here. You can use it, but you need to be aware when you can actually use it and when not, because otherwise you get very strange results, which might your superiors might love it, but it's probably not the right number, as you can see here, right? So if you need to iterate through a table, be aware that the iterator functions, the X functions, are the way to go. And otherwise, if you can actually use the sum function, then as you have seen, you need to either modify your data model by adding specific columns in here, what we have done here, total sales and total cost, or the data model maybe upfront already has the specific columns included, so you can use the sum function then to get your results. But that's actually the difference between the sumX function as an iterator function and the sum function. So hopefully that helps. If so, then please also give me feedback for that. And otherwise, thanks a lot for watching, and hopefully see you in the next video. Until then, best guys. Hey friends, welcome back. Now, in this video, we'd like to explore and train a little bit more with Power BI and DAX measures. So during the course, we already covered the top 10 clients related to a specific metric. In our case, it was the total profit. So let's actually explore this a little bit further. Let's say our superior or a colleague of us is coming and is asking for, could you please tell me what are the top 5 customers? Or let's say the bottom 5 customers based on a certain metric. Or let's say he or she is interested in what are the top 5 products or the top 10 products. Or what are the products we sell between a certain range? And could you please create a visualization which allows me to slice and dice that? So, okay, sure, we can do that. Let's explore that. Let's right click on the measures table to create the measure. And before I do this, please note that you can see here, I'm using the dataset of the second part. So the Power BI Advanced training, which allowed us to create this specific report at the end. So we do not need to reset up the whole data model structure and save some time. So you can open this from the resource section to follow along. So let me click on the plus symbol here. And then let's actually visualize. Maybe starting with the top, so the best 5 clients we have. So to do this, we can quite easily visualize at first our clients. So go with a customer company here in the orders table. I can tick this option, and then it gives me a table of all the 89 clients we have in the dataset. Then I could say, okay, I want to visualize my total sales, and then we can see here the total sales for each customer individually. So far, so good. Now, if we are asked to show the total or the best customers, that's not an issue. We can simply sort it, right? So if you hover over total sales, you can click on the sort option here, tick this option. You could also do the same if you click on the 3 dots and then go to sort by. But here you see that these are our top customers. And now they are sorted correctly. So far so good. What if we would like to create a visual? So it could be a bar chart, could be a whatever, yeah, a donut chart or whatever, but only showing the top, let's say top 5 customers based on the metric total sales. Could also be another metric, but let's stick to the total sales for now. Okay, let's explore that. You also feel free to just stop the video and try this out yourself, because we have done something kind of similar with the top 10 clients as a little hint here, but otherwise, please follow along with me. So let's right click on the measures table here, right click, create a new measure, and then let's just zoom in. Here we go. And this measure is now our top 5 clients. Spell it correctly, is equal to. And now I go to new line and I say for the top 5 clients, I want to calculate something. Remember, we want to change the filter context to only show the top 5. So we calculate the total sales. So total sales, and this is what we actually want to modify. So just refer, I think it's this one here, total sales, yes. So total sales expression and the modification, so the filter itself, the new filter context will be using the filter function, filter, a unique list of all our customers. So unique list could be given by the values function, returns a table with a unique list, exactly what we need for the specific column. So we're referring to the customer company. So from the orders table, let's search for order table first, and then customer company, this one. So this is our unique list, and this list of the 89 customers we want to filter. So filter by what? Well, by the total sales and by the ranking of the sales. So we can use the rank X function. Correct. Now because the rank X function is evaluated in the specific filter context, we need to remove the context. So we don't only show the rank of 1 for each of our customers. We want to use the all function to do this. So using all. And then we are referring to the orders TBL again, order TBL. And they're the customer company, this one. Let me close this here. Okay, that's that. And then we specify here we want to use an expression, the total sales again. So I'm searching for that from the measures table, this one. And by the way, if you want to choose a different metric, then of course simply replace the total sales here and here as well. So then we have this, and then we make sure that the order is descending because we want to have the top 5, right? So let's use descending here. Let's close this. And then as a filter expression, we want to make sure that the list is less, so the ranking of the customers is less or equal to, let's say 5, because that's what we say here, top 5 clients. Of course, you can modify this to your specific needs. And then I can close this here, and I also need to close the calculate function. Finally, I will copy all of this. And of course, I want to format this correctly. So I go in here, I paste it here inside, and then I format it here. Then I just wait a little bit, and there it is. Let's copy this here, and let's go back to our Power BI report and paste this inside. Okay, this is our measure. Let's press enter. And here we go. And now let's actually visualize that. Let's use a table like that. Let me just copy this table to save a little bit of time. Let's drag this in here, and let's remove the total sales from here. Okay, now we get a unique list of the customers, and now let's only switch to the top 5. Let's select here, top 5 clients, and now you see we got only 5 values in here. And if we sort them here, then you'll see here we got exactly the same names as the sorted list here. Quick stop, then the second one, third one, rattlesnake, and then this hungry, and so on. So exactly those top 5 clients, which are calculated, which now can be evaluated in each kind of visual. So if I go to the donut chart, I would see a donut chart and only my top 5 clients, right? If I use a bar chart, I would see the bar chart for only the top 5 clients, and so on. So that's exactly what I meant. Let me just go back and back again. So this is how we can get and show only the top 5 clients and also see their sales contribution. What if we'd like to see the worst 5 clients? How can we do this? Well, actually all we need to do is modify this one just a little bit. Because all we do is simply we take everything here, Control C to copy this, and then let's actually create a new measure. Right click on the measures table, click on new measure. Okay, here we go. We paste this inside and say these are the, let's say, worst 5 clients. Okay, worst 5 clients. And then we just modify this here and say ascending is in this greater or equal to 5. Sorry, less equal to 5 is fine. What I meant was descending here. That's what we modified. We say ascending. I need to spell it ascending here. Okay, so that's actually all we need to modify here. And then we evaluate that, worst 5 clients, press enter. And then let's actually Control C to copy this visual, Control V to paste it. And instead of having, just move it here, the top 5 clients, remove this, and let's go with the worst 5 clients. Take this option, and now you see we got here 5 clients. Let's actually also sort this. And here, and now if we scroll down in our complete sorted list, we would see exactly those names here appearing there as well, up to central, commercial, and so on. So that's exactly those. Quite easy and only slightly modified from the top 5 clients, right? And the great thing, if you want to change this, for instance, instead of the customers, I would like to see this for the products. All you need to do is go back to the measure, top 5 clients, for instance, and then instead of using the customer company, just use here the product, for instance. So let's do that. Just for the sake of this example, Control C to copy this. Again, we right click on the measures table, say new measure. Then we paste this inside. And then instead of the customer company, we use from the products table the product, or we use the product name. So product from the orders table, the product name. Here we go. This one here. And of course, we also want to modify this here for the ranking, right? So select this here as well. And we got here the product names. Of course, we should also rename the measure, top 5 products. So let's call this products. Press enter. And now we evaluate that. And let's have a look at that. Top 5 products. Also start with the product list. Let's go in here, say from the orders table here, we'd like to see the product name. Tick this. And then we take a look at the total sales in my case, which is a measure. Then we can sort this here. And we get all the products here, starting with Côte de Blé. And now if I go in here and maybe copy this here, Control V to paste it. Then we got this here as well. Make that a little bit smaller here. And instead of using the total sales here, I actually want to make this smaller here. Drag that here. Instead of all the total sales, I'd like to see in this case, where is it? The top 5 products. Select the measure and then also sort this here. And you'll see that we got exactly the same values as here, but only the top 5, right? And it could be top 10, top 7, whatever you specify here. So you only need to slightly modify it and you get all those insights in here, right? Okay, so in addition, I said at the beginning, what if we would like to calculate here, let's say products between a certain price range, right? What about that? Or let's say between a sales range. Let's do it this way. Okay, so let's actually get rid maybe of this one. We don't need this anymore. Also, we don't need to show all of them. Let's actually get rid of this one as well. So we got a little bit more space in here. So here we only show the top 5 products. Here, let me just move this up here. Top 5 products, customer company, and the worst 5 clients. Okay. Now let's say we would like to see, values for all the products between a certain sales threshold, above and or between two values, right? How to do this? Remember, to do this dynamically, we have the option to use scenario analysis. So what if parameters? So if I go to, in this case, modeling here, and I say I'd like to add a new parameter, click on the parameter option here, and then specify here the values. So let's say this is the say threshold, or let's say lower threshold. It should be a whole number, that's fine. And you see that the products are up to 153,000. So let's say we use a minimum of 0 and a maximum of, let's say, 200,000. So it's sure we cover all the products, right? So, and the increment will be, let's say increment is 1000, and the default value is 50,000 as an example. Okay. Then we add a slicer to the page, click on it, and then we are good to go and have here our slicer with threshold values. And we do the same for the second parameter. So this is the threshold lower. Let's create another parameter here and say this is the threshold upper. Threshold upper or upper threshold. It is a whole number, 0 to, let's say the same, 200,000. This should cover the whole range of sales for the specific product. Of course, in your specific dataset could be different. Of course, also, if you choose a different metric from the same dataset, could also be different. So, but I think the way is clear if we do it here. And then, of course, you can adjust this to your specific needs. So let's say default is also 50,000 here. That's what I specify. I click OK. And then we have a second slider in here, which is now the threshold upper, which also can be modified here. All right. So we got our two thresholds here, like this one and this one here. And all we need to do now is, let's actually drag this up here. And all we need to do now is simply create our measure to make sure we only cover the products between those two thresholds. So let's do that. Let's right click on the measures table, create a new measure. And here we go. And say, let's say products between, call this between, just an example. Of course, feel free to come up with a better name that I do here. Then for this name, for this formula here, we simply say, I want to calculate the total sales in my case. So total sales, which is this one here from the measures table. And I want to make sure that I want to filter them. I say filter. And then I want to have a unique list of my products. So kind of similar to what we've done already for the top and worst 5 products or customers. So filter values, a unique list of, in this case, the products. So products from the order table, product name. You could also probably use product ID, but let's go with product name. Okay. And then the filter expression, the second part, is that we want to make sure that the total sales, so total sales, this measure, is greater or equal. Let's say we include the threshold, then the threshold lower, the value. Get rid of that. And at the same time, and we use an ampersand here, double ampersand is the and symbol, is the and in Power BI, remember that. We want to make sure that the total sales here from the measures table is less or equal to the threshold upper. Here we go, this value. So both of these criteria must be fulfilled, and only then we want to show the total sales. So let's close this here, and then let's also close the calculate function. And finally, let's actually copy all of this, Control C to copy it, and I will go back here to my option to format this code a little bit, so it's easier for you to read. Click on format here, and let's evaluate that. Let's copy it here, copy, and I will go back to my report, take this option, paste it inside, and now it's formatted and a bit easier to read. So the syntax here is quite similar. So you see it's repeating for several insights the same way, but this time we simply check it that the specific price range is between, or the sales are between those two thresholds in here, using the double ampersand symbol. But the structure of the code using the filter function, values, and so on is exactly the same. So let's actually try that. Now we have here our products, so we need a product list. So let's actually, easy, Control C to copy from here, Control V to paste. So we have it already, our product list. We can get rid of the top 5 products because we don't need this anymore. Let's get rid of that. And now we have a unique list of our product names in here. You could also directly go to order table, click on it, then you also get your table structure, of course. I just wanted to save a little bit of time, so I copy things if I can do that. And now we need to add the specific, well, calculation we have done, right? So where is it? Let me just increase the size here so I can read it easier. Here, products between, there it is. I can tick this, make sure the table is still selected, click on the table, and then click on products between. Tick this option, and then we see here, these are the products. So not all the products, but only the products which are between. Make this bigger here, for instance. Also maybe here in size a little bit. so we can see all the products between those thresholds. Let's say we make it closer, so maybe let's say between 45 and 52, and we see we only got 3 products here which have been sold, or which have sales in total between those threshold values. And that's how that works. So hopefully that was interesting to you, hopefully that was helpful. As always, I encourage you, try this out yourself, and the pattern which we have covered here can be used certainly in your own DAX and Power BI reports as well. So now you know how to do it, and also feel free to take a look at the example from the resource section, and also of course rewatch the video if you want to and need, anytime. So that's it, hopefully that was helpful. As always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, bye guys. Hey friends, welcome to this little preview of the second Power BI masterclass, Expand Excellence. I just want to give you here a little information about what you can expect in the second class. And next to learning more on time intelligence and various DAX calculations, we also do some kind of visualization best practices. So for instance, we do here create some kind of navigation menu, which can be your landing page, as you can see here, which is available here. And also how to create these little icons here, for instance, which also might enhance your specific navigation or landing page. If I go to the final report, just as an example, I can click here, and then we learn about bookmarks extensively, how to use them and what to be aware of. What I mean by bookmarks is, for instance, I could see here currently my sales figures, but maybe I'm more interested in the profit. I can then trigger a profit bookmark, and you see that my visualization change here and give me more information about profit insights. I can also trigger a bookmark based on buttons. So if I select this one here, I can see the same as before, or I click there one more time, I can see then this one. This also be possible. Next to that, if I go back to my navigation, I also can go to my finance report, for instance. And if I go to this report, here we learn about how to create awesome pop-ups in Power BI, which can give your report and consumer more information. What I mean by that is if I click here, for instance, and trigger this, then I can see this pop-up window, which can give you more information for specific visualizations. And if I want to get rid of that, simply click somewhere on the screen, doesn't matter where, simply click here and it's gone. And we also talk about drill through in Power BI. So that means if I'm here on my finance report and now I'm interested in the United States, I want to see more data, I can then hover over the bar, and then I see here a drill through option. I can go to a detail page, click there, and then I drill into my data, and here I see detailed insights for USA. So that's everything we cover here. Let me go back, and much more. So hopefully that is interesting, and if so, then take a look at it. Thanks a lot. Hey friends, welcome to this new bonus video. Now, today I'd like to address with you a solution for the problem of cascading slicers. So what are cascading slicers, and what's the issue with them in Power BI? So let's explore that. You've seen I have the training dataset from the masterclass, and what I want to do is to create a simple visualization so we can see exactly what the problem is. So if I take from my orders table, maybe my customer country, I tick it, and then because I don't want to have a map, I would like to have maybe a bar chart, because then it's much easier to see. And now of course I need some kind of measure. So I will go to my measures table and simply use my total sales in here. Tick this option, and then I can see here all my countries and the total sales. Let me put it here in the middle, and then also maybe add also the labels, data labels. So we can see that the data will change depending on the slicers we apply. So, all right. So next let's say we gonna now go to our, where is it? The suppliers table. Let me just check. There it is, suppliers table. And here I'd like to use now my suppliers. So I go to supplier name, tick this option. By default, I get a list in here, but I switch it to a slicer. So like that. So now the report consumer has the option. He or she can now choose different kinds of supplier names in here. And based on the supplier, the data in the orders table will change. So I can click, for instance, for this one, tick this option, and you'll see that the data changes in here, right? So I untick this, I got my whole data set. Or if I hold my control key, I can also select several of them. That's also fine. By the way, if of course you would like to have some kind of drop-down list, you can also do this. go to the little down arrow here and then choose a drop down instead, if this is what you prefer for the slicers. And in the settings in Power BI, just want to mention this, there's also the option to add an apply button. Okay, but maybe let me go to the list because then it's easier to see, and also maybe increase the size here a little bit. So I go to the items here in the formatting section and choose text size, and let's say put in 15 in here. Okay, so that's fine. So now we can choose suppliers and filter our data. And maybe make this a little bit smaller, just I don't want the visuals to overlap. Okay, like that. That's fine. The reason why this works is kind of simple, because let's take a look at our data model here. Tick this option, and you see that we get a star schema and a one-to-many relationship from the suppliers table to the orders table. That is why I can choose any of my columns from the suppliers table and use it as a filter in a slicer, for instance, to filter my data from the orders table, which in this case is the customer country we have here, and also the total sales, which are also derived from the sales column in here from the orders table, right? Okay, so that works, and always remember the filter direction by default is from the one side to the star or the many side. This is also highlighted here with the little arrow here. Now, next, let's say we also want to have a slicer from the dates table. Let's go back to our report and now choose, in this case, the dates table. Here it is. And choose, for instance, the date, like that. And I like to have this as a slicer, so I choose slicer instead of table. And then I now will simply use, it's up to you whether you want to have this hierarchy, but here I right click and say I'd like to see this as a date, so I have a slider. Like, just a second, there it is. And now I want to choose this as going here and say I'd like to have this maybe, where is it? Between. Okay, so now I have my slider on here. So it's a little bit small concerning the numbers, but hopefully you can still read it. Otherwise, just follow me along. Here, I would like to now choose a specific range. And let's say I'm choosing here my, in this case, let's go to the, I think it's around here, 30th of August in 2020. You see that the data changes here, of course. And here now I would go also make this a little bit smaller. And let's say the report consumer, he or she chooses now a period, which is kind of, let's close. Let's go in here and maybe do this differently. September, and let's say we're gonna use the 6th of September in 2020. Now see, of course, we got a lot less data because our time frame is really narrowed down. And now I could choose one of my suppliers. Let's say I'm choosing here this first one, and then I can see data in here. Okay, not much, but at least the supplier provided here items which we have sold then to Sweden. Okay, next one, and you see the issue. So obviously now we have filtered the dates table to have only the data for a really specific window. On the other hand, we have another slicer which considers the suppliers, but some of them, actually, if we tick them, then there is no data in the view. So why is that? Well, the reason simply is there is no combination of sales between or within this narrow time frame and a supplier which provided, in this case, this Bigfoot breweries provided any kind of supplies to us which we have sold. And this supplier table, which you probably also have noticed, let me just remove this for now, is not filtered. So we chose to use filter the dates table here, but the suppliers table here as a slicer is not filtered. It still shows all the values. And that's what I meant with the cascading slicer problem or filter problem. Why is that happening? Well, to explore this, it's quite easy to go to the model view one more time and take a look at your model. So in our case, this is the example model we use, but of course, if you apply this to your own data, then it will behave exactly the same. The problem we face is in our star schema, the dimension tables, which are the tables on top, on the one side, those filter the facts table, which is the orders table, this one, but they do not filter each other, which means that if I select something from the dates table here, this will filter the orders table, but it will not filter the suppliers table. And the same is true for the employees table, for instance, or the other way around. Suppliers table can filter the orders table, but it cannot filter, by default at least, the dates table. Because the relationship is from the one side to the many side, and not from many side here, from the orders table, then back to the one side of the dates table. Now, of course, some would argue, okay, we can make this relationship bidirectional, so that the filter direction is from the many side to the one side as well. However, this is something you want to avoid as much as possible. If you have really a use case to enable bidirectional relationship, then do this. But if you don't, then try to avoid it as much as possible. Because if you enable bidirectional relationships and you have a really complex model, then Power BI will or might give you wrong results, depending on how you filter and slice and dice the data. So you need to be really, really careful when applying bidirectional relationships. And this is why I want to show you a better solution for that. So, we know that the suppliers table can only filter the orders table, and the same is true for the dates table, for instance. Dates table can also only filter the orders table, but not the suppliers table, and the other way around. But we can use actually a measure, our own measure, in order to make this actually happening, the filter between the dimension tables. So how do we do this? Let's go back to our report view in here. And now let's actually create a measure which simply checks whether there is data in the orders table for the specific supplier regarding the current filter in the report view we have. How we do this? Well, we right click on the measures table here and create a new measure. You can also do it here from the ribbon section if you want. But here I like to do it directly in here because then I have the measure inside my measures table. Let's take this and let's have a look. Just a second. And there's the measure. And now here, let's say I'll filter measure. Okay. You can name this whatever you like. But here I name it filter measure. And the formula itself is quite short because all I want to do for now is simply check, is there data in the orders table for this specific, in this case, supplier, regarding the current filter selection we have regarding the dates. So to do this, we simply check is empty. There's an is empty function, is empty, there it is. And this simply checks, let me just, here, returns true if the specified table or table expression is empty. That's all. So we just need to give it a table. Now the table we want to check is, of course, the orders table. So we simply type in orders table here, orders TBL, and close parentheses. And that's all. And now let's actually execute this. So this will give us a true or false. Okay, there's our measure. And let's quickly check that. Let's actually go in here. Remember, when I chose big food breweries, for instance, if I tick this option, I don't have any data. So let's go in here and say we'd like to actually switch this just for a minute to a table. So now we can see the supplier names. It's a little bit small, but believe me, the second entry here is big food breweries. So for now, I just avoided to make the size bigger. Just believe me, you can see that hopefully. Now let's actually check this is empty, what we've created. So the filter measure here, check this box and add it to the visual. And now you see we got trues and falses. And true, for instance, for big food breweries, as well as for the next one, as well as for this escargot nouveau, and so on. And all of them who return true are actually the ones who do not have any data in the sales table for this specific period we currently have selected. So if I click, for instance, this one, which also returns true here, let me click it, you see that there's also no data. So everything here is currently grayed out, but this just means there is no data. On the other hand, if I choose, for instance, this one, the first one, which specifies false, let me tick this option. Here you see you have data. So it's highlighted, right? Currently it's not completely filtered, it's just highlighted, but you can change the interaction if you want. If you go to the Format tab here, edit interactions, and just go to filtering here, then you see here the filtered data. So false means there is data. And if I go to one of the true ones, for instance, exotic liquids, then there is no data. Okay, so this helps us, this measure, to specify whether we actually want to show the supplier name or not. So let me just remove the filter measure for now from the table, because I want to revert it back to a slicer. Go to the slicer option here, and we got our slicer again. And the idea now is to use the measure we have created and simply filter the slicer. So you have the filter pane here. If you can't see it, just remember you just need to click here to expand it. And then you need to select the visual, in this case the slicer. And here you have the supplier name. And then you can add additional filters in here. Because for the supplier name, it's kind of simple because you only can do either select the specific supplier, or you can also use here, for instance, top N, basic, advanced filtering, and so on. But what I want to show you is now the following. As I said, drag the filter measure into the filter visual here. And if you do that, and now try to expand it, you'll see that this is not working currently. So the reason for this is it currently returns a Boolean value, which is true or false. And what we need is actually a number. So the measure should return a number like 1 and 0 in order to filter here. But this can be easily done if we convert the true and false into ones and zeros. To do this, let's just remove the measure for now and just go to the measure one more time. So here we go. And now just wrap all this, or the complete measure, into the integer function. So the integer function returns the true or false from the measure into ones and zeros. So 0 means it's a false, and 1 means it's true. Now let me close the parentheses here, and we should be good to go. Let's execute this. Okay, so that's our modified measure. And now if I drag this measure, select first the slicer in here, and now drag the filter measure one more time into the filter pane. And now say here, you can see that now we have the option to is less, is greater, and so on, because now we have a number. And if we now say is, so is exactly, and here you can type in a 0. 0 means it's false. Now if I click on apply, watch what happens with the supplier name. So remember, Bigfoot Breweries, for instance, didn't return any data. Also the next two didn't return any data for the specific time frame we have filtered. Now let me click apply. And now you see those are gone from the filter. And all the supplier names which remain here, if I take the first one here, I can see data. If I take the second one, see data. Third one, data. Fourth one, data, and so on. So now you can only select, or the report consumer can only select here suppliers which actually show data in here. And the same is true the other way around. Of course, if you, instead of using 0 here, go to the 1 and click apply. Now you see the Bigfoot Breweries and so on, and all those suppliers actually will return nothing down there. So you see, if I take this one, nothing, 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 and so on. And that's basically how you can create this cascading slicers, it's called. So that means that one slicer can filter another slicer even though you do not have bidirectional relationship enabled in the model. So let me just switch this back to, first let me untick this here, and let me switch this back to 0, click apply, and that's it, what we want to have. Now of course I can just remove this from the view, and now the report end consumer will get exactly what he or she wants. So he or she will, based on the dates table which is here filtered, I will get only the suppliers visible which are actually providing data and information, and this is how I can avoid for the other visuals in the view which are dependent on my orders table that they are empty or don't show any data. Okay? And this, as I said, is the much better option instead of using bidirectional filters. So for bidirectional relationships, There are use cases for that, but they are really specific. So if you can avoid them, then do it. Okay? And now you have learned a way which you can use in order to avoid the empty visuals after filtering, for instance, various slicers. Okay? And of course, finally, let me just say this can of course also be done the other way around. Because currently we have only created this for the supplier name, but of course you can apply the same filter logic to all the other measures from the other dimension tables. Okay? So that's it for this video. So hopefully that was helpful, and as always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Star Freelancer.